So let's start now. Welcome to the CCSP Focus webinar. So basically today I will tell you how to what is the approach you have to follow for the CCSP exam and what is the difference between going for the CCSP exam or other exams like AWS or Azure kind of things and all. And I'll tell you some key points you have to understand and remember in each domain of the CCSP exam and how to prepare your mindset for the exam. That's the whole thing. Okay, that's it. So before I start, let me just give you an introduction about my profile. My name is Krish. I'll be your instructor for this whole journey. So I'm a Microsoft certified trainer and I've been working in the industry for the last 16 plus years. And from 2010 onwards, I'm working with this cloud platform for various companies. I'm a consultant and trainer as well. That's my whole profile for information. So let's start now. First of all, we'll discuss about the CCSP exam, and then I'll tell you what is basically the difference between the CCSP exams and other exams, I'll take you to the domain-wise topics. So first of all, most people have the doubt about what exactly is a CCSP exam. Most people basically have the doubt what exactly is CCSP or what is the difference between the CCSP and other exams. So CCSP is a certification by the organization called as ISC Square. It's actually a combination of ISC Square and Cloud Security Alliance, but major part is handled by the ISC Square, the International Information Systems Security Certification Consortium. So it's a completely non-profit organization which is managing all this training for the last 20-30 years. So basically, it's a very vast experience they have. The main difference between going to the AWS certification or Azure certification or CCSP is basically the things they are providing. Like for example, if you go to AWS certification or Azure certification or all these kind of things, they are basically platform specific. Like for example, let's say if you learn AWS certification, you'll learn how to implement things on the AWS cloud platform. If you learn GCP, you'll learn how to implement things on the Google Cloud platform. But CCSP, like CCSK, is a complete vendor neutral certification. That means it's not basically we are covering every vendor, but there is a few more difference about this. The main difference is in AWS and Azure and other kind of certifications, we are mostly focusing on the hands-on perspective. Like we are focusing on how to implement those things in AWS or Azure or other cloud providers. Let me give you an example here. Let's say, for example, if I'm going to my AWS certification, I will basically learn what is AWS or what are the infrastructure available to AWS, what is AWS compute services, how to create a virtual machine, how to create a storage, how to create database. So all these things I will study in the AWS perspective. And that is a pure implementation tactical perspective. But at the same time, CCSP is a complete exam which is focusing on a strategic mindset. That means that you are working in an organization. Okay, you're basically working in an organization. When you work in an organization, the primary thing you have to understand is you have to work for the business. Like for example, let's say you're working in a company and whatever things you're doing in the company must be aligned with the business requirements. You know that, right? So what happens in that perspective, as you have everything to be aligned with your company requirements, so there must be some person in the company or there must be a team in the company to ensure that when you're planning for a cloud transition, let's say for example, my company is currently having on-premises. When I am planning to have a cloud transition, we have a lot of factors involved. We have a lot of risk involved. I'll discuss all that. We have a lot of benefits. So by understanding all these risk involved, like legal risk, data risk, compliance risk, regulatory factors, security. So by analyzing all these factors and making sure whatever things we are doing, it is aligned with our business requirements. That is the role of a CCSP certified person. Okay, that's it. This certification aims for its IT architecture, web and cloud security engineering, and especially like the information security governance, risk and compliance, and IT auditing as well. But understand that this is not a certification for a person who is basically want to work in AWS or Azure. This is for people who want to completely manage the cloud transition or cloud process in the company. Like I'll give you a strategy for this. I'll give an example for this. So whenever you're going for any kind of companies, for every company, there will be a mission and a vision. For every company, there will be having a mission and vision. So basically, they have a mission and vision, and to accomplish this mission and vision, they have something called as a strategy. And to implement the strategy, they have something called as a tactics. So the CCSP guy is basically a person who is working on the strategic perspective. I'll give an example. Now I'm going to cloud platform and my cloud experts or my cloud architects are basically giving me a lot of solutions. To find out which solution is the best one for my requirement, Are they meeting my compliance requirements? I'll give an example. Let's say, for example, I want to basically do some financial transactions and all. For example, if I want to comply with the PCI DSS, is my cloud provider able to provide me the factors to comply with the PCI DSS certification, or what all things I have to keep in mind if I want to basically ensure this thing to work effectively? So all these things must be taken care by the CCSP certified person. So that is what which we do here. This certification aims to professionals who is involved in the day-to-day activities related to managing the cloud platform. Okay, that's it. And as we discussed, it's basically by the ISC Square and the Cloud Security Alliance. So we will discuss in each of them. Like for example, definitely that in cloud platform we have a lot of advantages and we have a lot of disadvantages. We have a lot of drawbacks. So as a CCSP, you have to understand the drawbacks and you have to find out the effective solutions for it. Let's say, for example, while learning CCSP, one thing which most people will note is basically we are talking more about the risk involved in the cloud platform. But you have to understand that even if we have a lot of risk involved in the cloud platform, the benefits we are getting is very much better, very much more than the risk we are taking. That is why basically people want to move to cloud. Let's discuss about that in very much detail. So before that, let me take you through the exam first of all, then I'll go to the domain wise things, which will cover all these things. Okay, that's it. So these are the CCSP domains. So basically we have total 6 domains to study in the CCSP exam. The CCSP exam has revised on August 2019, and like some 5-10% things changed, but it's very much interesting now. So we have total 6 domains in CCSP, which starting from the cloud concepts, architecture and design, which will cover the basics of cloud computing, then specifically moving to the cloud data security, and then moving to the cloud platform and infrastructure security. In that we will basically, definitely I'll explain. In that cloud platform infrastructure security, we are thinking in the perspective of a cloud service provider more. Why? Because let's say, for example, if I am going to be a cloud service provider, I will tell basically what all things I have to keep in mind, and how to ensure the security of your applications in the cloud platform, and the cloud security operations, and the legal and risk and compliance factors which is involved. These are the total 6 domains in CCSP exam. So what we are going to discuss about is all about this whole 6 domains. Okay, that's it. So just that is one thing I want to discuss before CCSP. So basically most people ask me, what is the difference between CCSP and CCSK? So CCSP stands for Certified Cloud Security Professional, which is basically by the ISC Square and the Cloud Security Alliance. And CCSK stands for Certificate of Cloud Security Knowledge. It's basically by the Cloud Security Alliance itself. Okay, so this is I felt that this basically for both these exams, the things are almost same. Like for example, if you have a knowledge in CCSK, the CCSP exam will be much more easier to you. But CCSK is a bit more from the practical perspective, like they have some labs as well. So basically in CCSP, what happens is we have a document called as Cloud Security Alliance Guidance, a guidance manual, and it's more onto the technical mindset. But CCSP is basically more from the management and tactical point of a strategic point of view. And one more thing about CCSK is an open book exam. Like we can basically write the exam whenever we want. We can basically book the exam. It's almost $384 for the exam. You have to book the exam for CCSK, and whenever you want, you can write the exam. But even if we say CCSK is an open book exam, you have to understand one main thing, that it is not easy. Like you can't basically open the book and read everything and write the exam. Because why? Because the question can be a bit much tricky. You have to prepare well and understand the concepts if you want to pass CCSK also. That's a very important thing. Most people basically get confused, as CCSK is open book exam. It is very easy. It is not that much easy. You have to basically prepare well if you want to appear for CCSK also. And CCSK gives you a second chance as well. Like for example, even if you fail the exam for the first time, you can write the exam once again. So these are the benefits of CCSK. Like I'll give an example. So basically in CCSP, we have total 6 domains, right? We have total 6 domains. The same 6 domains is divided into 12 modules in CCSK. The total 6 domains in CCSP is divided into 12 modules in CCSK, but a little more less. Like it's not that much complicated like the CCSP exam. And definitely a person, if you want to pursue CCSP and if you want to start with a simple certification first, you can go to CCSK. Otherwise, you can directly go to CCSP. I'll tell you what all prerequisites you must have to appear for CCSP also. And one more thing is there, as we discussed, basically for CCSP, you have to basically have a predefined set of experience as per their recommending. So basically, once you pass the exam, you will get a notification and endorsement link, and in that link you have to basically apply for the certification. And basically, when you fill the form, you have to demonstrate that you have minimum 5 years of experience in information technology, out of which 3 years in information security and 1 year in any domains of the CCSP exam. And that is one thing. So basically, let's say for most people ask me, Krish, can I do CCSP without the relevant experience? Definitely you can do CCSP without experience also. The problem is you will become only the IC square associate. You can't become a CCSP. You will become, once you pass the CCSP exam, you will become an IC square associate, and you will be having 6 years in front of you to basically prove your experience. So within 6 years, if you are able to prove your experience, you can basically become a CCSP. Okay, that's it. And if you already have a certification like CISSP or something, you don't have to basically worry about the experience. They will not be verifying all the experience. Why? Because you're already CISSP certified. That's it. So we are going to discuss more technically in this today. So before that, just a few more things in the exam perspective. So the CCSP exam is revised to 3 hours. Basically, before 2019 August, it was basically 4 hours. Now the exam is 3 hours only. The CCSP exam is now 3 hours. That is, you have basically 180 minutes for the exam, and the exam fees is basically $600. And as for now, the exam is not available online, but I have basically heard some news that they may make it online. But as for now, if the exam is not online, you have to book the exam and you have to go to the Pearson VUE center and write the exam only. Okay, that's it. There is a chance of the CCSP exams and everything can become online, but as for now, you have to basically go to the exam center and write the exam. So you have total 125 questions in the exam, but there is one thing you have to keep in mind. Out of these 125 questions, 100 questions is basically what you are given score for. Don't forget, you are getting score only for the 100 questions. For the rest 25 questions, you are not getting any score. Like for example, this is for research and development. Don't forget, this particular 25 questions are not given any kind of score. It's basically for research and development. Okay, the exam is basically having 125 questions, 25 questions for research and development, and 100 questions for the scoring actually. And basically it's a multiple choice questions you have, so basically, you know, it's a bit more easy, but you must have a very clear idea about the topics if you want to pass. And we don't have a cat-like format for CCSP like we have in CISSP. Okay, that's it. And the total passing mark score is basically 700. But understand that even if you pass or fail, they will not give you the score. They will tell you the domain. If you pass, they will show you your passed, and if you fail, they will show you the domain-wise proficiencies. You will not be able to see the score. Okay, that's the whole thing. Hope it's clear for you. That's it. So the next one is, so we are going to discuss about the exam key points, and then we will basically go to the how to prepare for the exam. Okay, so first of all, we will go to the domain wise details. The first domain which we have to study in the CCSP exam is the cloud concepts, architecture and design. So basically, when you refer to the curriculum of this exam, I strongly recommend you always go to the official curriculum provided by IC Square. So you can go to the IC Square website and you will basically get this particular PDF file. It's basically free of cost. You can get this PDF file, which will give you a complete idea about the exams. See this. So this is basically the CCSP exam outline. You can basically download this from the IC Square website. It's basically free of cost. Okay. You can basically go to this domain-wise topics. Just give me a second. Yeah, here. So as you can see that this is the domain-wise weightage as I shown you. Okay, always before the exam you have to verify this curriculum if there is a change or something. So in the domain one, I'll tell you what all things you are studying. First of all, we'll start with the cloud computing concepts, architecture and design. So in this, we have to understand what is cloud computing. So what is cloud computing, team? So basically, most people think about cloud computing as something which is basically, you know, when we say the word cloud computing, I'll give you a very simple idea on this. When you say the word cloud computing, we have to understand two words here. We have two words. The first word is we have a cloud, and second word is we have a computing. So we have basically two words here. So we have two words here, cloud and computing. What is cloud computing? So cloud means anything which we access via internet. So anything which we access via internet is what you call as cloud. And anything, or basically the compute things, like for example, the CPU capacity, the memory capacity, the storage capacity, the network capacity, all these things are called as the computing. So providing this computing things, okay, providing this computing things via internet is called as cloud computing. Providing this computing things via internet is called as cloud computing. So basically, the cloud computing is something which is, we can have a definition for this. Cloud is basically described by the use of collection of services, applications, and information and infrastructure comprised of a pool of compute, network, and storage resources. So team, that is what you call as cloud computing. So when you discuss about cloud computing, a few things you have to always remember here for the exam. The first thing you have to remember here is pooled resources. Pooled resources. The second thing you have to understand about here is called as orchestration. These two words are very important. First of all, we have to, when we define the cloud computing, we have to understand these two words, pooled resources or resource pooling, and the second one is orchestration. These two words you have to understand in detail. First of all, what is a pooled resource? I'll give an example, team. Let's say, for example, when you go to cloud computing, when you go to cloud platform, are you getting physical machines or virtual machines? You are getting virtual machines. When you basically say the word cloud computing, you're actually getting virtual machines. See this is basically a VM. The reason is because I'll give you this example. So in the cloud computing, I'll give you the features of cloud computing. We basically call it as this on-demand self-service, broad network access. Then we have something called as a multi-tenancy, rapid elasticity and scalability, resource pooling. So we have all these things. So if you want to get this elasticity and scalability, if you want to get this multi-tenancy, if you want to get this on-demand self-service, if you want to have all these things, okay, if you want to basically have all these things, there must be a resource pooling. Why? Because let's assume that I have a customer in cloud platform. I'm a customer in cloud platform. So what happens is I am basically requesting them to basically give me a physical hardware. The cloud platform, I am requesting them to give me a physical hardware. So what happens when I am giving them an option to give a physical hardware? Definitely they can provide this. But there are two problems. The main problem which we have with the physical hardware is cost. The customer has to pay a lot more cost than having a virtual machine in the cloud platform if they go for a physical machine. The second problem with having a physical machine is, let's say for example, this customer is telling that they want to have a scalability, they want to have more memory capacity, they want to have more CPU capacity. So what happens? I have to basically go to the physical hardware in the back end. So open the piece of hardware, add more RAM to it. So what happens? Things are much hectic. So what happens? So physical machines is not at all feasible in the cloud platform. So what happens is the cloud service provider will basically have a pool of machines like this. See this, they have a pool of computers like this. Okay, we call it as compute pool. We call it as compute pool. So basically the cloud service provider will have a compute pool like this, which will contain the CPU and memory. In the cloud platform, if somebody asks you what is compute, answer them that we are talking about CPU and memory. We are not talking about storage. Don't confuse. When you talk about the compute pool in the cloud platform, we are talking about CPU and memory. So what we have to understand here is the cloud provider is basically having a pool of resources, and this pool of resources are combined together, and that combining together is called as abstraction. We are combining this particular hardware together to a single one. Like for example, let's say if I have a 2 GB RAM here, 2 GB RAM here. So what happens is, so we have total 5 computers here. So what happens? We have 10 GB RAM. Like the same way, we have a pool of resources abstracted together to a single unit. Like I'll give an example. So basically, when you go to the on-premises, you have a SAN storage, right? In the SAN storage, you have seen that you have a lot of hard disk here. Hard disk number 1, hard disk number 2, 3, 4, 5. You have a lot of hard disk or SSD inside the SAN storage, but you are addressing them as a single unit, right? Like the same way in the cloud platform also, we are basically addressing our servers, everything as a single. The cloud provider will combine it to a single unit, and that combination, or basically they are combining this huge pool of resources to a single unit, is what you call as abstraction. And like the same way of having a compute pool, they will be having a storage pool as well, a lot of storage devices. So what is advantage there? When they have a compute pool and storage pool, whenever the customer is requesting for some kind of hardware, let's say for example, when I say the word server, I have a specific kind of requirement. When you say the word server, you have a specific requirement, right? So what happens when you request for a hardware? Because there is a compute and storage pool and there is virtualization, the cloud service provider will be able to provide you with the required capacity of CPU, memory, storage, and networking. Okay, that's it. So this is basically what you call as a resource pooling. This word is very important, resource pooling. The next word you have to understand in this cloud computing is basically what you call as orchestration. It is very important word, orchestration. So orchestration means basically, what is orchestration? When I say the word orchestration means, like, team, what is automation? There is a word called as automation. So what does it mean by automation? Let's say, for example, if I say I want to automate something, what does it mean by automation? Exactly, the process will not have any manual intervention, less manual. I agree with that. So basically what happens is, let's say I'll give an example. So every day I am telling you basically, okay, I am telling my Linux administrator to basically take a backup automatically from every machines on a particular time. So what happens? So instead of doing the task manually, I can write a script for that, right? Just I write a script. So what happens? And when the script will run, the task will complete automatically. So we have a particular requirement. We are automating the writing a script or doing some automation task like that and running the script, and what happens, the task will be completed without manual intervention. That's what we call as automation. So let me show you an example here. Let me basically show you an example here. I'm just trying to log into my cloud console and to show you an example. And for CCSP, one thing I always recommend is basically when you go for CCSP and all, better if you have a basic knowledge about the cloud providers, like at least AWS or Azure. If you have a overview knowledge, it can be very much helpful. Why? Because you can basically easily correlate things and all. That's my suggestion for you. So I'm basically logging on to my cloud platform. I'm using AWS now. Any platform, there's the same only. Okay, that's it. AWS or Azure, you can go to any platform, it's same only. See, so I'm currently in my AWS console. Okay, I'm opening a service called as Amazon EC2. I'm opening a service called as Amazon EC2. So let me see, let me try to create a server. In AWS, we call the servers as instances. Okay, that's the only difference. In Azure, we call it as VMs. So I'm going to launch a server. So the first thing I have to do when I launch a server in AWS is basically, let me show you that. See, they will ask me to select an operating system. So I can select an operating system whenever I want. So basically I'm selecting Windows Server example. So when I select Windows Server, an automation script will run in the background. Okay, when I select Windows Server, an automation script will run in the background and go to the repository of images and take this image for me. Got it? When I click on this, our automation script will run in the backend and go to the image pool of images and take this particular image for my requirement. First automation script. Then when I basically choose the instance type here, what happens is from the compute pool, they are going to take a single core CPU and 1 GB RAM for me. If I'm selecting this one, it will basically go to the compute pool and select a dual core CPU and 8 GB RAM. Okay, so here also an automation script will run. Again, the next step, they are asking me for a network. So what happens? I can basically select the network, and this will basically select or create a virtual network for me. And here, when I click on hardware, what happens? Again, here also an automation script will run to give me some storage I am recommending. So once I click on launch instance, what happens is once I click on this button, a lot of automation script will run in the background. Multiple automation script will run in the background to accomplish the complete task called as creating an instance. Got it? So we have some 5 or 6 or 7. We have multiple automation tasks running together in a sequence to give me a result. The result is called as the instance or VM, right? To get this result, some 8 or 9 or 10 automation script or task is running, and this kind of multiple automation task running together or running in a sequence to provide a proper result is what you call as orchestration. Don't forget, that is the easiest way we can define orchestration. Multiple automation tasks running in a sequence in a predefined manner or order to give you a result like VM or database or cluster or network or node is basically what you call as a orchestration. Running multiple automation tasks in a sequence in a particular manner is what you call as orchestration. Okay, that's it. So in the cloud platform, everything is orchestrated. I'll give an example. See, now I am currently in my AWS Management Console. How do I know what is happening in the background? What is the underlying platform? I will not be able to see any kind of underlying platform. I am just working on the Management Console, and through the Management Console, I will be able to issue the requirements or API calls. In the backend, this orchestrator will do all the activities for me. So I'll tell you the one more thing about orchestration. So team, what do you mean by orchestra in the music? What do you mean by orchestra in the music? Like for example, multiple musical instruments working together. Like for example, let's say we have a guitar, we have a keyboard, we have a violin. We have multiple musical instruments working together in a particular sequence, in a particular rhythm to produce a music. Like the same way, multiple automation tasks running in a particular sequence, in an order, in a manner to provide a result is what you call as an orchestration in the cloud platform. Okay, that's it. So now I hope you're able to understand about the difference between the word called as automation orchestration. So we discussed two words now, the pool of resources, resource pooling, and the orchestration. These words are very important for you to understand for the CCSP exam. The next one, which is very important for the exam, is about the cloud computing roles. So what does it mean by cloud computing roles? See, we have a lot of entities in the cloud platform. Like for example, basically, I am a customer. Let's say, for example, let's say I'm basically working as a part of a company called as Infosec Train. So what happens is Infosec Train is basically having to trying to host all their infrastructure in AWS. So AWS is basically called as the cloud service provider. Infosec Train is basically called as the cloud service consumer or cloud service customer, whatever it is. They can basically call this company as the cloud service customer or consumer, and the provider is called as the cloud service provider. But we have more job roles in this. We have not only this, we have more job roles. I'll give you one more example, team. Let's say, for example, now we have the customer is called as Infosec Train. So inside Infosec Train, or let's say inside this particular company, let's take any example, any company. So inside this company, there is a guy called as Krish working there. So what is this guy's job role there? In the perspective of cloud service provider, he is a cloud computing user or cloud service administrator. So we have a lot of sub roles inside this also, like the cloud service user, the cloud service administrator, and they're all okay. We have a lot of job roles like that. Like we have a cloud service user and we have a cloud service administrator and all. Okay. Lot of job roles will be there inside this each main roles. So the common job roles are listed here. You have to basically understand very clearly, and especially if you want to pass the exam, I strongly recommend you basically have a very good idea about the job roles. Don't forget, team, it's very, very important. There is a standard you have to understand here also. I'll basically give you an explanation about that. As per so there is a standard called as ISO 17789, which defines the various job roles in the cloud computing. Okay, which defines the various job roles in the cloud computing. So that also we can understand, we have to understand. And the key roles are cloud service customer. What is a cloud service customer, team? What is what do you call as a cloud service customer? The cloud service customer is basically the principal stakeholder. Don't forget, the cloud service customer is the principal stakeholder, that guy who is basically having the key roles in the cloud platform. Basically, this guy is consuming the cloud services, and they are the most important entity for the cloud service provider. Why? Because they are handling the whole, or they are basically having the whole running the whole cloud business, right? That's it. And they are the principal stakeholder that uses the cloud computing services. Then we have a job role called as the cloud service provider. So when I say the word cloud service provider, who is a cloud service provider? The cloud service provider is a company which provides services and basically ensures that basically the customers are getting the proper services, proper availability, and everything, which gives them proper value. So I'll give you a question here, team. Let's say, for example, when you basically go to a company, let's say, for example, you came to this webinar, you basically join a training, or you basically want to get AWS, or you want to adopt AWS platform, or your company want to buy something, or whatever things you're doing, what you're expecting, the thing you're expecting is what you call as the quality of service. So for every customer, what matters is the quality of service, QoS, quality of service. Like for example, let's say you take a Netflix subscription, you take an Amazon Prime subscription, you take a AWS platform, you take Azure platform. So whenever you're going to any of these things, we have what we say, we basically have something called as we must get something called as a quality of service, and that is what we are expecting from them. Okay, and to provide this quality of service, the cloud service provider has to basically work end-to-end effectively. And we have one more very important job role to understand here called as cloud service partner. That's a very important thing. We have a job role called as cloud service partner. I'll give an example. The main example is cloud service auditor. The cloud service auditor, the cloud service broker, and all is basically the example of the cloud service partner. So when I say the word cloud service broker, I'll give a simple example for that. When I say the word cloud service broker, let's say if you have multiple cloud providers in your company, and nowadays in the companies you can see that there is a lot of cloud providers like AWS, Azure, etc. And in 2021, I have seen that this multi-cloud architecture is what trending now. Multi-cloud architecture, and then the hybrid cloud is basically the trending technologies in 2021. So basically for this one, if you want to have multi-cloud architecture, you have a lot of cloud providers like AWS, Azure, a lot of cloud providers are there. But how do you basically manage them effectively? So if you want to like managing the users in the cloud platform, managing the storage, managing the resources, monitoring them, to have a centralized management of multiple cloud accounts and multiple cloud providers, there must be a centralized way for that. And that centralized way is called as a simple cloud broker. We have a lot more things inside that, but that is a simple role. Like the same way to ensure the cloud computing clarity, to have a auditing and all, we basically have a cloud service auditor who performs the independent examination of cloud service and security controls. Okay, this is what we have to understand. And then the next is super important for us. the key cloud computing characteristics. You have to understand the key cloud computing characteristics. Like for example, let's say basically when you go to any cloud platform, if you want to say something as cloud platform, if I want to say something as a cloud platform, it must have 5 features as per the NIST, National Institutes of Standards and Technology. You must have these 5 features if you want to say something as cloud platform. Okay, so that is, we have a on-demand self-service, we have a broad network access, we have a multi-tenancy, we have a rapid elasticity, we have a resource pooling, and we have a measured service. You must have these 5 this main features if you want to say something as cloud platform. Let me show you an example here. See this. The first one is we have something called as a on-demand self-service. We have something called as a on-demand self-service. So what does it mean by that? It means that when you see the word on-demand self-service, it's all about ensuring that without a manual interaction, you can basically work with the cloud platform. I'll give an example. So team, let's say for example, you want to deploy a server in your on-premises, or let's say for example, you work in a project and you want to basically deploy a server for your project. So what is the first thing you have to do, team? What is the first thing you have to do? If you want to basically deploy some new resources or hardware for your project, what is the first thing you have to do?
I have to request for the resource.
You have to basically request for, that is, you have to get the approval from the top management. That is, that you have to get the approval from the top management. That is what you call as first one. Then once you get the approval, you have to basically then inform the operations team or basically a team which basically provides you the hardware, and a human administrator. That's a key point. A human administrator has to basically manually go to the console and create everything for you. So you can't do anything. You have to wait for a person in the back end to do the job for you, and it will take at least 1 to 2 days, right, minimum, for the approval. You get the approval, you have to get the things deployed, so it will take a long time. So it is not a self-service. You have to basically wait for a person in the backend to basically do the things to you, right? That's what you call as. But in the cloud platform, see, now I was basically going to the AWS console here. I was able to create a server without any interaction. I don't have to wait for a person in the cloud service provider side to deploy this for you. Everything is automated. That's what you call as a on-demand self-service, without waiting for a person to basically, give you the resource or give you the service. You can basically get the service automatically. That's what you call as on-demand self-service. Then we have a word called as broad network access. Like for example, let's say now all of you are working from home, and as per the new records, we have a 18% increase in the usage of cloud computing in last year. The 18% of usage is increased in cloud platform in 2020. Why? Because everybody started working from home, and companies want to dissolve their office buildings. They don't want to basically have an office building and basically work from office. Everybody want to basically have a work from home culture now. So broad network access means you can work from anywhere in the world, from any devices like mobile phone or tablets or iPads or desktops or laptops or any device you want. Like for example, let's say when you will see, like I am currently in my home, I don't have a laptop example. If I have a mobile phone, I must be able to work from my mobile phone. Okay, so broad network access means that you must be able to work or able to access the services through multiple kind of devices from multiple locations. Then we have something called as resource pooling, which we already discussed. That is, we have multiple resources pooled together to get the benefit. Then we have a rapid elasticity. That I'll give you an example. So what is rapid elasticity? So basically what happens is you have a cloud platform here. So whenever I want, I can create resources with any capacity. Like now I am telling you that team, please create a server which is having some 24 GB of RAM or 24 TB of RAM. You can create that in next 5 to 10 minutes maximum. And if I want to have a simple configuration, I can have it. So any configuration as per my requirements, I can create or manage without any kind of delay. Okay, that's what you call as a rapid elasticity. I can whenever I want, I can create things, and whenever I want, I can remove things. That's what you call as rapid elasticity. But there's a lot of problems also with that. I'll explain that. Okay, then the next one is, finally we have a measured service. That is one of the main things which people go to the cloud platform. It's a pay as you go model. In the cloud platform, you have a elasticity, and whenever you want to get some resources, you can create it, you can use it, and once your requirement is over, you can remove it, and you will be charged only for that particular time you're using it. So it is more economical, more cost effective and all. These are the 5 benefits of cloud computing which we have, right? So as a CCSP, like the same way you understand the benefits, you have to understand the drawbacks also. So all these things have a lot of drawbacks. What is the main drawback which we have here? The main drawback which we have here is, I'll give a simple example, team. Let's say, for example, we have a resource pooling. So resource pooling means I am basically sharing my whole infrastructure with multiple customers. Let's say when I go to AWS or when I go to Azure or any public cloud providers, I'm having a huge pool of resources there, which is shared by multiple people. See, you are having some very sensitive and very confidential informations. So this very sensitive information is basically stored in a place where other people's information is also stored. So that is the highest risk in cloud platform. The highest risk in cloud platform is basically the resource pooling, because we have multi-tenancy. In the exam or in the when you learn these things, the first thing you have to understand is what is the primary drawbacks of cloud platform. The primary security drawback of cloud platform is the multi-tenancy. So multi-tenancy will basically bring you a lot of challenges. Why? Because you're basically sharing your infrastructure and hardware with multiple customers, and even you don't know that people. See, let's say for example, it's like you basically use public transport system while you have a COVID pandemic situation. Same way, what happens is when you basically go to the cloud platform, you are storing your data in the cloud service provider's storage where they have multiple customers' data. And we don't know how much secure the data is. We don't know how much malicious the data is. We have to basically store near to that. But even if I say there is a separation, there is no physical separation. There is only logical separation. So this is the primary security challenge in the cloud platform. Okay. So like the same way, all these characteristics are having a lot of drawbacks also. It's very important for us to understand the drawbacks of this cloud computing characteristics for the exam. And finally, the very important thing, basically the building block technologies. When I say building block technologies, like we have virtualization, we have storage, we have network, we have database, we have orchestration. We discussed about that and already discussed, right? When we see the word, see, when somebody asks you what are the key characteristics or key factors the cloud is built on, we can say compute, you can say storage, you can say network, and you can say virtualization. So these are the four main things the cloud is built on. Compute, which stands about the CPU and memory. We have a storage, we have network, and we have virtualization. So as a cloud service consumer, you have to understand that these are the things which is a cloud platform is built on. Okay, that's it. So that's about the cloud computing concepts. You have to have very clear understanding of this if you want to basically pass the exam. Then we have to discuss about the cloud reference architecture. So cloud reference architecture means, like, it's basically a very important thing you have to understand. Like, we have to understand the various activities we have to basically do in the cloud platform. And we have to understand that these words are very important. What is interoperability? What is portability? What is reversibility? What is available? So these words are very important. So I'll give you a simple example for this. You have, as a customer, you have to clearly understand the difference between interoperability and portability. What is interoperability and portability? Let's assume that when you're basically going to a cloud service provider called as AWS or Azure, any cloud provider, whenever your requirement is over, let's say for example, whenever you want to basically move from one cloud service provider to another. Let's say for example, now I am working in AWS. I want to move from AWS to Azure, or I want to move from Azure to AWS, or any cloud provider. Whenever you want to move from one cloud provider to another, you must be able to easily do that. That's what you call as portability. The lack of portability is called as vendor lock-in. Vendor lock-in, you are stuck with the wrong provider due to any reason. If you are not able to move from one provider to another, if you want, is called as vendor lock-in. So vendor lock-in is basically lack of portability. Don't forget. Like the same way you have a interoperability. So what is interoperability? Interoperability means what happens is, let's say for example, I have some resource in AWS. I must be able to ensure that these things in AWS must be able to work together with certain components in Azure also. So I may have some application components in AWS and other application components in Azure or any other cloud service provider. I must be able to work in a combined manner. That's what we call as interoperability. So you must having a clear understanding about the interoperability and portability. Then we have to understand about the different cloud service categories, like the SaaS, IaaS, and PaaS. So whenever you go to any cloud provider, not only Amazon, whenever you go to any cloud service provider, understand that you must have, or you have something called as, a cloud services. In the cloud platform, the cloud provider is able to provide you things with the help of services. Basically, everything is called as services. See this? Now you go to AWS here. In AWS, you can see that there is a lot of services here. See this? All these things you see here is called as services. So these are all services, right? So these services you have here, is divided into three categories, mainly three categories. We have basically more, but All these things are subcategories of things which we are going to explain. So we have basically 3 categories of cloud services. We have a IaaS service, we have a PaaS service, and we have a SaaS service. Whatever services we are going to a cloud service provider, it will be either IaaS or PaaS or SaaS. So as a CCSP guy, you have to understand what is the criteria for choosing IaaS or PaaS or SaaS, and what is the risk of choosing IaaS, or what is the risk of choosing PaaS, and what is the risk of choosing SaaS. Okay, so let me give an example, team. Let's say, for example, I hope all of you are aware of the word called as PaaS platform. Okay, so tell me, do we have any drawbacks for moving to the PaaS platform? Anyone? Any drawbacks in moving to the PaaS platform? Okay, when you basically have a PaaS platform, the advantage is the cloud service provider will take care of a lot of things. Let me show you a diagram here to basically give you a clarity. So let me open a diagram for you, which I have prepared, which will give you a clarity for this. So this is the picture, team. This is the picture which we have to understand. In the PaaS platform, what we have to understand is, see this is the PaaS platform. The cloud provider will basically take care of a lot of things. Like, for example, when you go to the IaaS platform, what happens is, in the IaaS platform, you know that the cloud provider will provide you the infrastructure, and from the operating system you install onwards, it's basically a responsibility of the cloud service consumer. This is taken by the cloud service consumer. This is basically taken care by the cloud service provider. Okay, it is like you are having your own infrastructure in the cloud platform. But the same time, what is the problem if you have the PaaS platform? The PaaS platform, we can see that, see, we have multiple layers. Like, see this, our operating system, our database, underlying database system, our platform like Java, .NET, PHP, Ruby. So all our runtimes and platforms is handled by the cloud service provider, and you have to just put your code and run your application. So team, what is the risk involved in this thing? See here, basically what happens is you are relying a lot more on the cloud service provider. Like, for example, let's say if I'll give a simple example. So I'm currently going to my AWS platform or Azure or whatever it is. I'm going to any platform. So in this platform, what happens is when you basically go to AWS, so I'm going to a service called as Elastic Beanstalk. The Elastic Beanstalk is basically we can say it as a PaaS platform. Okay, it's basically a PaaS platform. So what happens is I click on create an application. Very simple. I can just put the application name. I can choose my platform I want. So I have to rely on the cloud service provider to ensure the complete security of the platform. Why? Because the platform is completely managed. This is what you call as a platform. The platform is completely managed by the cloud service provider. See this? This is completely managed by the cloud service provider. Let's say, for example, there is some issues. Let's say, for example, after some time there is an attack happened or something wrong happened. Can I get the OS log files on this? Can I get the OS log files on this? I can't get the OS log files. I have to rely on the cloud service provider. See, I have an issue. I have some issue. So is there any way I can basically get some log files? No, I can't get the log files here. I have to basically rely on the cloud service provider if you want to get the OS log files. And in most cases, they will not be able to share you that. Why? Because it can contain multiple customers' data. Why? Because the same platform is basically shared with multiple customers, like the application from one customer, the application from another customer. So all these applications are shared with the same platform. So because of that, the cloud service provider will be also finding it reluctant to basically share the underlying infrastructure. You have to rely a lot more on the cloud service provider in this pricing strategy. Do we have any benefits for this particular model? Yes, we have a lot of benefits. It's not about fast. It's not about fast. The benefit is managing. The cloud service provider will manage everything for you. To make it more simple, like from the like OS updates, patching, maintenance, replication, failover, and the middleware like the database updates, database patching, maintenance, high availability, or the security, and the platform security, platform updation. All these things will be managed by the cloud service provider. I have to just worry about my data and application. Like, for example, I have to ensure that my code is free from vulnerabilities and my application level things are secure. Except that everything will be managed by the cloud service provider. Lesser management for the user. But the problem is you are relying a lot more on the cloud service provider, and a lot of customizations are there which you can't do in this cloud platform, particular PaaS platform. Okay, that's it. So as a cloud customer, you have to basically have an understanding of these things in very much detail. If you go for CCSP exam, that's a very important thing. Okay, so you have to understand about the cloud service capabilities. Okay, that's it. Then you have to understand about the cloud deployment models. This is something which is very important for you. I'll tell you why it is important. The reason is because Most people basically have a confusion between this. Let's say, for example, team, give me some example for a public cloud provider. Okay, GCP, Google. Then we have Amazon, we have Azure. So all these guys are your Gmail is a public cloud application. So all these things are public cloud providers. And when you go for a public cloud provider, you have a infrastructure which is shared by multiple customers. Like when you go to AWS, or even when you, let's say, to make it more simple, if you go to Google Drive or any platform like this, you have to rely on the cloud service provider. You have to completely rely on the cloud service provider, okay, in the public cloud platform. But at the same time, when you go for a private cloud, that's a very important thing you have to understand. When you basically go for a private cloud, let me give an example here. We can say two types of private cloud. One is basically called as on-premises private cloud, on-premises private cloud, and the other is off-premises private cloud. Okay, we have an on-premises private cloud and we have an off-premises private cloud. What is the difference between these two? The difference is, when you say the word on-premises private cloud, you're talking about the cloud platform, or you're talking about the data center you have in the on-premises. There is no third party, or there is no cloud service provider. You have your own data center. You are making it a cloud platform. So Krish, what is the difference between on-premises cloud and on-premises data center? The difference is, the on-premises cloud platform, you have all the features of cloud computing in your data center. That's what you call as on-premises cloud platform. Okay, so when you go to on-premises, what is the advantage, team? When you basically have an on-premises private cloud platform, what is advantage there? You have full control. You are the cloud service provider, you are the consumer. That is the best thing about the private cloud, on-premises private cloud. But what is the problem there? You are the cloud service provider and you are the consumer, so that you have to manage it completely. If there is no cloud provider involved, there comes our second risk in the cloud platform. The primary risk in the cloud platform we already discussed, multi-tenancy. The second risk in the cloud platform is third-party administrators. What is third-party administrator? We are basically relying on the cloud service provider. The cloud service provider is always considered as third party. So these two risks can be eliminated in the on-premises cloud platform. Let's say I have a company called as ABC. So when I have a company called as ABC Corp, I will be able to have my data center who is processing the data of my customers. That's what I call as on-premises. So there is no multi-tenancy and third-party administrators. Do we really don't have a multi-tenancy team? In the on-premises, do we have any kind of multi-tenancy? Just think about it. In the on-premises cloud platform, do you have any multi-tenancy? Yes, we have a multi-tenancy. Inside the organization itself, we have multiple teams or multiple projects running. So what happens? Multiple organizational units are working in the same data center or working in the same cloud platform, which must be having a proper isolation each other. So there also is we are having some level of multi-tenancy, but not like the on the public cloud providers. And the next one is called as off-premises private cloud. Off-premises private cloud. So what does it mean by off-premises private cloud platform? You are going to a third-party cloud service provider. But the difference is, instead of having your data center in the on-premises, you are having your data center at the cloud service provider, is what you call as off-premises private cloud. To make it more simple, I'll give an example, team. So this is basically my AWS console. So let's say, what is advantage if I basically go to my on-premises? I can basically create my own network. I can create my own means network security. Like I can basically have firewalls. I can basically have IDS, IPS systems. I can basically have routers. I can basically have routing. I can basically have VPN. I can basically configure and I can create zones, segmentation. I can do a lot of things. All these things you can do in the cloud service provider if you opt for a off-premises private cloud service. In the AWS, the best example is called as VPC. In AWS, we have a service called as VPC, which is completely on-premise or off-premises private cloud platform. We have a VPC, which is basically a off-premises private cloud platform. Let me show you an example here. See this VPC. So VPC in AWS, in Azure, we call it as VNet. This VPC or VNet will let you basically have your own data center inside the cloud service provider. This VPC or VNet will basically allow you to have your own data center inside the cloud service provider. Got it? That's what we call as a VPC. So I can configure my routing, I can configure my modems, routers, firewalls, DHCP servers. I can basically configure NATing. I can basically configure VPN. I can do a lot of things in the cloud platform. The only difference is, instead of having your data center in the on-premises, or instead of you managing your data center, you are relying on the cloud provider's logical segment data center. That's what we call as off-premises private cloud. Okay, that's it. And tell me if I'm going a bit fast. You hope you're able to understand. Okay, that's it. And the most important factor we have to understand is about the SLA. In the exam, I 100% guarantee you that you will get a question on this. The reason is because, let's say, for example, you say that, Krish, I want this in cloud platform, I want this in cloud platform. So how can you basically talk to your cloud service provider? Basically, let's say, for example, if I say the word talking to the cloud service provider, there is no way you can talk to the cloud service provider without a clarity. If you want to talk to your cloud service provider, okay, if you want to talk to your cloud service provider, you must have a legal bonding for it. That legal factor is called as contract, and SLA. SLA is a part of contract. So what are things which matters to you must be written in the contract. Like for example, you're telling me that, Krish, I want to have a 99.99% availability. I want to have a data security of this level. So like the same way, you will tell me a lot of things. All these things, if you want to ensure, you have to basically mention that in the contract. There is no way you can basically talk to a cloud service provider without having a proper contract. The only way to talk to a cloud service provider is to have a effective contract. Okay, so having a SLA and contract and the components of SLA is something which is very important for you to understand for the exam. Okay, and finally we have a word called as impact of relevant technologies. This is one. Okay, this is very important. Impact of relevant technologies. Okay, so team, here what happens is we have an impact of related technologies. So what happens is we have multiple technologies here. Like for example, we have a machine learning, we have a AI, we have a blockchain, we have a IoT. We have a lot of technologies we have to understand. This is basically something which is newly introduced in cloud in this particular curriculum. Basically from the 2019 August onwards, we have these topics in the exam. So what is the role of all these things in cloud platform? That is what we have to understand here. So team, when we say machine learning is an application of artificial intelligence. Don't forget, machine learning is basically an application of artificial intelligence. So let's say, for example, now you are basically having a lot of things like Alexa, you have a Siri, you have a lot of things like that. And basically your devices are able to communicate and work together. And you have a IoT also. What does it mean by IoT you have? When I say the word IoT, what does it mean by that? IoT means, okay, IoT means what happens is you basically have a lot of devices and these devices are able to communicate each other. I'll give an example. So basically when you go to a cloud service provider like Amazon or any cloud service provider, we can see there is a lot of new services in the IoT and machine learning part. See this? See, you have a huge number of list of services in the machine learning and AI part. Why? Because now a lot of things are basically using this machine learning service. I'll give an example. So what are the main problem which I basically go for IoT or anything, any kind of things like that? The primary thing is you want to have a lot of CPU capacity. When you want to go for IoT or things like that, you want to have a CPU capacity, you want to have more memory capacity, you want to have more analytics, you want to get cheaper cost. So you have a lot of requirements for having effective machine learning and blockchain or IoT technologies. So let's say, for example, I have a lot of sensors. Let me show you a picture here, which will give you clarity. Just give me a second. Let me show you a very important picture, which will give you clarity on this. See this. So here what happens is you can see that we have a lot of sensors. See this, we have all these things you are basically called as various sensors in various devices, like your smartwatches, your pacemakers. We have a lot of sensors and a lot of devices here. So all these sensors are sending some data for processing. They are sending a huge amount of data for doing the processing. Okay, they are sending a huge amount of data for doing the processing. So what happens? So all this data are sent to the cloud platform for processing, and it is analyzed in the cloud platform. The data is analyzed in the platform, and this is basically used for a lot of applications like medical applications or emergency services or other functionalities. So the cloud can provide with very high processing capabilities, very high storage capabilities, very high data analytics and classification capabilities in a very cheaper cost. That is why all these particular technologies rely basically more on the cloud platform. Okay, that's it. So that is something which we have to understand very much in detail. Why? Because it's you can expect at least one question from this. This is a new topic, and also it's very important, relevant now. See, I'll give an example. So here what happens is I'm just showing an example here. So we have a service called as Amazon Recognition. So when I basically go to this recognition, what happens? This service will be able to identify the face of a person. This a particular service will be able to correlate images. compare images. So all these activities can be done. Okay, all these activities can be done, and these things can produce effective results. But if I try to do all these things in the on-premises, I have a lot of time consuming. It requires a lot of memory and CPU intensive activities. But when you go to the cloud platform, everything is handled by the cloud provider itself, and the cost is very much cheaper. That's very important. And one more thing I want to tell you as a part of this, the most important thing you have to study as a part of which called as containers. So containerization plays a key role in cloud computing nowadays. Why? Because so team, basically when this technology came in the market, what is the name of the common container platforms in the world now? We have a lot of things, like we have a Docker, we have a Kubernetes, we have a LXC, we have a lot of container platforms. So what happens is, basically, if I try to build all these container platforms in the on-premises, the primary trouble is both the resources and management. So when I basically go to the cloud platform, what happens? You can build more effective and more easy containers or container applications without the headache of managing the underlying hardware. You don't have to worry about the underlying hardware, and you have an extensive amount of hardware. You have a massive amount of hardware in the cloud platform, and how much capacity you need, this basically cloud platform can build you that or bring you that. That's why containers are basically nowadays moving to the cloud platform. Like you can get all the common container platforms like Docker or Kubernetes or LXC, all these things in the cloud platform. Okay, that's it. So the next one is understand security concepts relevant to cloud computing. Understand the security concepts relevant to cloud computing. So basically the primary thing which we have to understand is basically the cryptography and key management. I will tell you that this particular topic we have is one of the most important topics we have to understand in this. Cryptography and key management. It's a super important topic for us. The reason is because when you basically go to any cloud platform, the primary thing is you have a multi-tenancy. You know that in the cloud platform, you have something called as a multi-tenancy. When you basically have a multi-tenancy, what is the problem you have? What is the problem you have in multi-tenancy? That is, you know that basically you're sharing your hardware with the multiple customers. And what is the effective solution for multi-tenancy? The primary solutions for multi-tenancy is to have an access control and to have an encryption. These are the key solutions for multi-tenancy. The first one is encryption, the second one is access control. Definitely security is the problem. So what happens is multi-tenancy, and for the solution is basically encryption and access control. So when we say the word encryption, there is one challenge again coming up. I'll tell you an example. Let's say, for example, now I'm telling you that there is we want to have encryption. So what is encryption? We are converting, or we are using techniques to basically convert a well-known format to unknown format. Okay, so when you do encryption, what all things you have? The first thing is, when you basically do encryption, the first thing is you have a data which you want to encrypt. You have a data which you want to encrypt. The second one is, the first thing is you want to have a data you want to encrypt. The second one is you have to have an algorithm. Okay, the first one is you want to basically have a data. The second one is you basically want to have an algorithm. And the third one is you have to have the key files. Don't forget, when you want to basically do encryption, you have to have three things: a data, the encryption algorithm, and the encryption key file. So which component of these things are most sensitive and most important, team? Tell me, which of these three components are most sensitive and most important? The key file. Exactly, the key file. The reason is because if the key file is basically leaked, or basically if the key file is got access to that, but the attacker get access to the key file, what happens? The data can be very easily compromised, because without a key file, let's say for example, if the attacker is able to get the encrypted data, he can't do anything. So only if he get the key file, he will be able to open the data. So storing the key file is something which is super important for us to understand. We have various methods for storing the key files in the cloud platform. But as a CCSP, you have to understand the best practice. What is the best practice? The best practice is to ensure that the key file is not stored with the cloud service provider who is storing the data. Ensure that the key file is not stored with the cloud service provider who is storing your data. The key file must be stored separately from the cloud service provider who is storing the data. Why? Because otherwise what happens is, if you basically give the data and the key file to the same provider, there's a higher risk of data leakage. Or what if the provider will basically be able to access your data? So it is a very best practice. You can, if you can, you can basically have your key management in the on-premises also if you want. Okay, that's it. The next one is you have a access control. Okay, you have an access control. So there is one problem with encryption. The primary problem you have to understand about encryption is about the complexity. So team, is it possible for all of us to basically have an encryption? Basically, yeah, that is purely based on your requirements. If you basically, if you are able to manage your own hardware-based key management devices, if you're able to manage your key files in the customer premise, you can go for it. Otherwise, you can go to some other cloud providers also. Yeah, I'll show you that. Definitely, I'll tell you that. KMS and all, definitely. So first of all, tell me team, what is the complexity with encryption? Encryption is not possible everywhere. Basically, if you want to encrypt all the data, it is not possible. You have to, because first of all, you have to understand the complexity of encryption, or you have to understand the requirements for encryption. It's not easy as you think. Okay. So what happens is the cryptography and key management is something which is very important. Why? Because the encryption is, it is not easy for us to basically have the encryption for every kind of data. And I'll give you a simple example. Let's say, for example, we have three types of data. We have a data at rest. We have a data in motion, or let's say we have a data in transit. Then we have a data in use. So we can, and what is data at rest? The data which is basically stored on some kind of storage device is called as data at rest. The data which is stored on some kind of like hard disk or SSD or tape drives or anywhere, we can call as data at rest. And we can have a lot of encryption for it, like file encryption, volume encryption, disk encryption, all. At the same time, for data in motion or data in transit, what do you mean by that? The data is transferred through a network. Like for example, when you open a website, the data is getting transferred to a website. When you're trying to send some data to your cloud platform, so it's data in transit. So here also we have an encryption. Give an example for encryption for data in transit, team. Anyone? Example for an encryption mechanism for data in transit? TLS, VPN, etc. Right? SSL, TLS, etc. Exactly. And what is the encryption for data in use? So for data in use, there is no encryption. Okay. So for data in use, the problem is that, see, now let's say, for example, I am showing you my sensitive file here, and I'm telling you that, team, please don't take a picture of this, or please don't basically record this. You can do it, right? The reason is because even if I basically, provide encryption and all, okay, even if I basically provide encryption and all, in the other things it's possible, but in the case of data in use, the data is currently used for some activity. At that time, it is not possible for us to basically have a encryption. So that is why there is no effective encryption for data in use. But one technology is coming up called as homomorphic encryption. Homomorphic encryption. Okay, that's it. Then the next one is we have to understand about, and one more thing I want to tell you, team. So basically, when you talk about encryption and key management, I want to tell you about the HSM and KMS. I just want to tell you about this. It's very important. That's why. So let's say, for example, how do you store a key file? Either you can store your encryption key files in a software. A lot of softwares are there in the market. Either we can store our encryption data or encryption key files in a software-based storage device, or you can store your key files, not the data. I'm talking about key files. You can store the key files which you use for encryption in something called as a hardware device, and that hardware device is what you call as HSM, hardware security module. So we have a device called as HSM. You can basically see this. I'll show you an example here. See, we have a lot of HSM devices in the market now. See, like Encipher, SafeNet, Leona, a lot of companies are basically producing these HSM devices, which you can have it in the on-premise. But these devices are not designed to store your data. These devices are designed to store your key files. Don't forget, these devices are not designed to store your data. These devices are designed to store your key files. Okay. And let's say, for example, I am storing my key files in the HSM device. If somebody tried to tamper this device, what happens? If somebody tried to tamper this device will basically erase all the contents inside it. So this is more secure. So if you want to basically get the FIPS 140-2 compliance and all, okay. If you want to be complying with the FIPS 140-2 and all, or 303, whatever it is, you have to basically have a HSM device. But if you have this hardware-based key management in your on-premises, it can be too challenging. The complexity can be too challenging. That is why the cloud providers nowadays provide a service called as KMS, key management service, which they will use HSM service in the backend. Okay. The only difference is if you go for an on-premise HSM device, the key management is completely in your own premises and the key file will be inside the HSM device only. But when you go to the cloud service provider, the key management and the hardware HSM device will be at the cloud provider side. And in most cases, the KMS service provided by the cloud service providers will be multi-tenant. Don't forget, okay? That's it. You have to understand about the data and media sanitization. So what does it mean by data and media sanitization? So team, tell me, what is the best way to remove your data completely in the on-premises? Let's say, for example, so my question here is, tell me team, what is the best way to ensure your data is completely removed in the on-premises or wiped in the on-premises? The best way to ensure that the data is completely removed in the on-premises is to physically destroy the storage device. You have to basically take the hard disk or SSD, you can basically crush it and basically physically destroy the storage device. The best way you can ensure the data is removed in the on-premises. But you can't basically go to the cloud service provider's data center and do this activity, right? You can't basically go to the cloud service provider's premise and do this. You have to strictly do some kind of software mechanisms which you are allowed to. The best mechanism in the cloud platform for removing the data securely is called as cryptographic erasure, crypto shredding. We call as crypto shredding. It's called as crypto shredding, DING, or cryptographic erasure. The best way to ensure your data is removed in the cloud platform is to have a crypto shredding or cryptographic erasure. It is not about physical destruction. Why? Because we can't guarantee that there is a physical destruction. See, I'll give you a simple example. Let me see. Give you a simple example here. So I'm going to the cloud platform here. Let's say this is my cloud platform. So my question here is, in this cloud platform, what happens is I have a storage device called as Amazon S3. Okay, I have a storage device called as Amazon S3. See this, Amazon S3. So what happens is, my question here is, when I basically delete this data in the cloud platform, let's say for example, I'm going to delete this data. Click on delete and I click on delete. So it is showing me that it is deleted. But what is the guarantee I have? It is deleted. So there is no guarantee that it is deleted. It can be still inside that. So what we can do? We can't do anything. The only thing which we can do is called as cryptographic erasure or crypto shredding. That's it. That's why we basically use encryption for that. Let me show you an example here. See this. So what happens is you're having a data here. Okay. The data is basically encrypted with something called as a data key. Okay, so we are encrypting this data with a data key file. This is a key file. Okay, I am having a data. This data is encrypted with the help of a data key file, and this data key file is encrypted with the help of a master key file. Okay, so we have a data key and we are basically encrypting this data key with a master key file. Okay, we are encrypting the data key with a master key file. Okay, so if I want to basically decrypt this data, first of all I have to use the master key to decrypt this data key and then use this data key to basically decrypt the data, right? So what happens in this kind of scenarios, what we can do is I can basically delete these two key files. Okay, I can basically delete these two key files. Okay, I can basically delete these two key files and this data can't be recovered. That's what you call as cryptographic erasure or crypto shredding. Don't forget, we have a data. The data can be deleted or data can be encrypted with the help of a data key, and the data key can be encrypted with the help of a customer master key, and these two key files will be deleted, so the data will not be recoverable. Is what you call as crypto shredding or cryptographic erasure. Okay, got it? The next one is network security. In the cloud platform, we have to understand the word called as defense in depth. This is a very important word everybody has to understand. Even if you go to any certification, you have to understand this word called as defense in depth. What does it mean by the defense in depth? Having a multi-layered security architecture. Like, I'll give an example. So how many of you wear a mask to prevent this COVID issue? Anybody who is basically wearing a mask to prevent this COVID issue? I have seen many people basically wearing a mask to prevent this COVID. Why you have a multi-layered mask for that? You can have a single layer, right? Why do you have 3 or 4 layer masks when you basically wear this mask and all, face mask and all? The reason is because you know that it will be able to filter the germs very effectively. Like the same way, let's say for example, I have a firewall. I know that my firewall is basically very strong and my firewall is able to meet all my security requirements. But I can't guarantee that everything will be filtered by this firewall. There is a chance that firewall can fail, right? That is why we must have one more layer of security like IPS or IDS, something like that. Again, For if I have, let's say we have a DLP solution, if it fails, we must have a IRM solution. Like I must have multiple layers of security. Why? Because if I don't have a multi-layered security architecture, I will not be able to provide the effectiveness. This is the key point you have to understand the exam. For any security control which is directly managing a threat or directly mitigating a threat, there must be a backup control to catch the failure of the first one. That's very important. Okay, that's it. So this is something which you have to understand very much. And you have to understand various threats in the virtualization also in the cloud platform. Then you have to understand about the cloud secure data lifecycle. See, there is a data lifecycle defined by ISO square called as secure data lifecycle. We call it as CSDLC. So what happens is, from the creation of data to the deletion of data, we are basically dividing the steps into, or we are basically dividing the data into multiple stages called as cloud data lifecycle. This is 100% guaranteed testable in the exam, because when you talk about the cloud platform, you have to understand that we have different kinds of data. So I'll give you a simple way to remember all these things. We basically call it as CSUSAD. This is the acronym for you to remember that. CSUSAD: create, store, use, share, archive, destroy. This is very important for you to understand. If you want to learn CCSP or any kind of exams like this, understand which phase of the cloud data lifecycle is your data. Okay, this is super important for you to understand. Okay, that's it. Then we have to understand about the BCDR. So team, what is the difference between having a BCP and DR? What is the difference between BC and DR? Is it same only, or we have a difference there? Let's assume, I'll give an example there. Let's assume that I'm having a data center. Okay, I'm having a data center. See, this is where we have our data center. Okay, so what happens is, this is my data center, and let's assume that if due to any reason, basically all my customers are accessing all my services and everything from this data center. Let's say, for example, I am using AWS region 1 or Azure region 1. So due to any reason, if this particular data center goes down, I must ensure that my business operations will continue. My customers are not affected by having a backup data center. So I must be able to ensure that my cloud service, my business or my operations will continue without interruption. The ability to continue operating in case of a disaster is called as business continuity. So by having a multiple data center or multiple architecture, what happens? Even if one fails, my business will continue automatically from the other location. That's what we call as business continuity. Okay, BC. And when I say the word DR, what is a DR? DR means, let's say, for example, this site went down, this primary site went down. When this primary site goes down, how or effort or time or cost, all these factors which basically involved to bring back this site to operation is what we call as disaster recovery. Disaster recovery is all from the technical perspective, and business continuity all from the availability perspective. So what happens is, basically what happens is, we have to ensure that the disaster struck site will be able to recover as per my requirements, is what we call as disaster recovery. So business continuity is all about ensuring that my business will continue even in case of a disaster. And DR means how I can basically recover my infrastructure which is struck by a disaster back to operation. Okay, this is something which you have to understand. Then the next thing which we have to understand is called as the cost benefit analysis. So there is a word called as total cost of ownership. There's a word called as total cost of ownership. So what does it mean by total cost of ownership, team? Let me give an example. Let's say, what is the total cost of ownership for your car? When you use a car, when you buy a car, what is the total cost of ownership you have? So basically, yeah, we have a purchasing cost, then we have a maintenance cost, then you're paying parking fee, you're paying for fuel. No, it's not about the on-road price when you buy. It's not about that. See, starting from the yearly insurance you're paying, to the tax you're giving to the government, to the fuel price, to the fuel tax, to the air, you're just checking the air in your car tire, and then you're putting the fuel, your maintenance, the toll you're paying, the cost, the tag. So everything like this is basically something which you call as a total cost of ownership, and the yearly insurance. So basically it's all about total. Like the same way, see, I say that okay team, I'm going to buy a particular server for my purpose. So what is the total cost of ownership for this? Like how long I can use this? Let's say 3 years. So what is the cost of power supply? How much power I have? How much cost it will determine me for the power supply? How much manpower I require? So a lot of things are there which basically defines the cost, the license cost and all. But at the same time, when you go to the cloud platform, see what is the benefit you're getting and how much TCO can be reduced. So based on that, see, definitely most people think that cloud is basically good for every organization. But to be honest, in my experience, I'll tell you, cloud is not for everyone. Even if I say cloud is basically the best thing you can get, but the problem is cloud is not for everyone. For certain businesses, cloud is not good, but that is purely based on the requirements actually. So first of all, you have to do a cost benefit analysis and plan accordingly. Then only you can have an effective cloud cost model. If you're not aware of the cloud services, if you're not aware of how much they are charging you for the requirements, you will not be able to provide, or you will not be able to get the value. Okay, that's it. Then we discuss about the word called as portability, interoperability, vendor lock-in already, and understand the various security constraints you have to understand for the different cloud platforms like cloud services. And finally, how can you evaluate the cloud service providers? I'll give an example, team. Let's say, for example, what is a way to verify? Let's say, for example, you're telling me that, Krish, I'm basically following all the proper standards for data security. What is a proper mechanism for me to verify something? Say, if I want to know you're following the proper security practice in your organization, what is the best practice? How can I basically verify that? We have to do auditing. Auditing is if you want to ensure something, if you want to basically verify something, you have to audit. Okay, so what happens is, so team, the only way to verify something is to have an audit. If you want to verify something, the only way is to have an audit. Okay, the only way is to have an audit. So the point here is, you are auditing something, and definitely we have auditors for that. We have a ISO auditing, we have different kinds of auditing for that. But is it possible for me to take my auditor or take an auditor to the cloud service provider's premise and do the auditing? No, we can't basically go to the cloud service provider's premise and do the auditing. Okay, we can't go to the cloud service provider's premises and do the auditing. Okay, we have to rely on what they are giving. Krish, how can we rely on that, what they're giving? See, I am telling you that I am certified on these things. It is not a good idea, right? That is why we have to rely on third-party audit reports. Basically, when you go to the cloud service platform, you can see a lot of third-party audit reports, which is done by international organizations, which is not biased to the cloud service provider. See, AWS audit reports. Any cloud platform, they will basically give you audit. See this SOC reports, a lot of you can basically see a lot of reports here. See this PCDSS, SOC reports. You can see a lot of things like this. By basically going through this, you will be able to understand the various compliance and audit reports provided by, or basically adopted by, the cloud service provider. And once you verify that, you can have more trust on the cloud service provider. And these are basically given by the bodies which is not having any relation with the cloud service provider. Okay, these are basically given by the body which is basically not having no relation to the cloud service provider. See this, let me show you an example here. See, all these things you see here, like the ISO certifications, AICPA certifications, the DOD, SRG, FedRAMP, FERPA, FISMA, HIPAA, all these things you SCIPDA, Canada, all these things you see here are basically various audit reports and the compliance reports given by the cloud service provider. And these are all given by the organizations which is not at all having any kind of biasing to the cloud service provider. So we can have a more trust on that. Okay, that's it. And don't forget, if you want to verify something, the only option is auditing. Okay, that's it. That's about the domain one, and domain one is pretty easy if you basically understand the concepts very clear. So team, the CCSP exam is all about critical thinking. You must be able to think effectively if you want to pass a CCSP exam. Okay, the next one is domain two. Domain two is all about the cloud data security. Okay, domain two is all about the cloud data security. So this is the largest domain in the CCSP exam. Okay, even if we basically think the domain one is the largest, domain one is covering the 17% of the exam, and this is basically covering 19%. The largest domain in the CCSP exam, the cloud data security. So this domain is basically a bit revised in the new curriculum. So I'll tell you how it works in this domain. So first thing which we have to understand is, in this domain, as we discussed, we have to understand the different kinds of data in the, or different states of data in the data lifecycle. So we discussed about the CSUSAD: create, store, use, share, archive, destroy. You have to understand what exactly is happening to the data in each of these data lifecycle phases, and what are the effective mechanisms to manage it. I'll give an example. So we discussed about something called as data in use, right? And I already told you that there is no mechanism for us to basically ensure the security of data, because basically there is no encryption. So in the exam, they will ask you, what is the upcoming encryption technology for this data in use? There is a technology for encryption coming up for this data in use, which is called as homomorphic encryption. Homomorphic encryption. Okay, this is something which is coming up upcoming for the data in use, but in the exam they will ask you this. It is just in concept now only. It is basically not at all having a implementation part now. It's just on research now. It's basically in testing also now. It's what you call as homomorphic encryption. So what is that? So for data in use, the only thing we can do is a homomorphic encryption. So my question here is, let's say for example, if let's say I have a data here, and this data is completely encrypted. This data is completely encrypted. So if I want to do some processing on this data, what is the first thing I have to do? If I want to do some processing on this data which is encrypted, what is the first thing I have to do? We have to decrypt it. The first thing we have to do is to decrypt it. So once you decrypt the data, you can basically do all the operations. But when you decrypt, what happens? The security is lost. That is why in this upcoming technology called as homomorphic encryption, we can do the mathematical operations like arithmetic and logical operations on the data without decrypting it. Like if I want to do some mathematical calculations or some kind of operations like that, I can do it on the data which is encrypted without decrypting it. That's what you call as homomorphic encryption. So you have to understand that concept. And the next thing which we have to understand in the cloud platform is called as data dispersion. So team, before I explain the data dispersion, what is the RAID? What do you mean by RAID? See, when we talk about data, we have a lot of constraints. Like, for example, we want performance, we want redundancy, we want security, we want failover. So we have a lot of requirements. So RAID is a technology, redundant array of independent disk or redundant array of inexpensive disk. It's a technology which will basically help us to share or basically divide my data into multiple pieces and store across multiple storage devices for performance, for availability, for security, and a lot of factors. And based on the requirement, we have different types of RAID. We have RAID levels actually. So level 0, or let's say RAID level 1, RAID level 2, RAID level 3. Like we have multiple RAID levels for its various purposes. Like for example, I'll give you a simple example. If I basically say RAID level 1, let me show an example here. See, when I basically go to RAID level 0, what happens is, so I have a piece of data. Let's assume that I have a piece of data, like I have a data called as ABCDEF. So if I have this data, I am dividing this data into multiple pieces, and the first part is stored in this first hard disk, second is stored in the second hard disk, third is in the second hard disk, fourth in the first hard disk, fourth in the second hard disk. Like I will split the data into store it into multiple devices. As multiple devices are storing this data, what is advantage there? It will basically give me more performance, because the same time simultaneously multiple storage devices are writing the data for me. So what happens? It can give me more performance. But at the same time, if I basically go to RAID 1, what is the problem there? If I basically go to RAID 1, whatever data I have in the first hard disk, the exact replica will be there in the second hard disk. Like we have more, like we have a RAID 5, like this is what you call as RAID 5. So like we have a lot of RAID levels for different requirements. So the same concept in cloud is called as data dispersion. So basically dividing the data and storing it in multiple locations is what you call as data dispersion. But when you talk about data dispersion, we have to understand one word here called as data residency. What is data residency? So as per the compliance or and other factors, legal and compliance factors, I have to basically make sure that my data is stored in a specific geographical location. I'll give a simple example, team. So what is the data privacy and security regulation in European region? What do you call that's the data privacy and security regulation in European region? It's what you call as GDPR. Like the same way, basically, when you go to US, you have a HIPAA, you have a PCI DSS, you have a FISMA, you have a FERPA, you have a COPPA, you have a lot of things like that. So for all these things, they have to ensure that the data is basically stored and processed only in a specific location. So before storing data in a cloud platform, that is something which is super important to understand. As a CCSP guy, you have to understand that the data is stored in a specific geographic location, and whatever things go wrong, the data will not go outside. Why? Let's say, for example, I basically go to a cloud service provider, let's say AWS, and let's say, let me give you a simple example, which I always say in my courses and all. The first one is, let's say, for example, I own a bank. Okay, I own a bank. So we have a lot of customers who is basically putting the money and to the bank. Okay, and the bank is basically storing all these things in a cloud platform like Azure, or let's say AWS, or let's say Oracle, or any cloud platform. My question here is, let's say if the cloud service, let's say let's say this is currently in India. So what happens if this particular cloud service provider accidentally or intentionally, whatever it is, if they accidentally or intentionally store your data in some other location than India, or if they accidentally delete some data, if they accidentally copy some data, or if they accidentally leak some data, who is answerable to the Reserve Bank of India and the customers? The cloud service provider or the bank? It will always be the bank only, right? The bank is responsible. Why? Because the bank is the data owner and the cloud provider is data custodian. So even if you, this is a key point you have to remove for exam. Even if you say you go to IaaS or PaaS or SaaS or AWS or Azure or Google or any cloud platform or any cloud model or any deployment model, the data owner is always responsible for the data. Whatever things happen, you are responsible for it. Tomorrow if something goes wrong, it's your responsibility only. You are responsible for it. Got it? Like for example, let's say tomorrow, let's say if the cloud service provider do something wrong, again you are responsible for it. But basically the whole point here is, if you talk about the GRC or data security and everything, by the end the customer is, or the data owner is basically responsible for the requirement. Why? Because whatever things go wrong, it's your responsibility only. So what happens is that you can basically go to the court of law for the cloud service provider, but basically what happens is, by the end, in the perspective of government, you have to answer that, right? That's it. So let's say that's about data dispersion. Then this is a super important topic. We have to understand the various type of storages available in the cloud platform. So let's say, for example, team, when you go to on-premises, you have a pen drive, you have a memory card, you have a hard disk, you have a SSD, you have a SAN device, you have a NAS device, you have a lot of things like this. Why? And you have a RAM, you have you have a cache memory, you have a virtual memory. Why you do have all this kind of memories? Why can't you have a single type of memory? Like, I'll give an example. What is the main difference between hard disk and SSD team? Performance, the speed and performance. That's it. The only thing is speed and performance, nothing more. Like for example, let's say hard SSD can basically work some 100 times faster than the normal hard disk. That's why, but nowadays basically people go for SSD, and the modern operating systems and modern applications are completely designed for SSD only. Okay, that's one point. Like the same way, you know that, let's say, okay, but what is the problem? The cost. If you want to buy a 1 TB SSD, you can get it for a cheaper price. But you basically go for a 1 TB, sorry, 1 TB hard disk, it's a cheaper price. When you basically go for a 1 TB SSD, the cost can be high. So the problem is, it's all based on our requirement. Like the same way in the cloud platform also, we have various kinds of storages. And I want to tell you a simple example for this. In the IaaS platform, we can say we have two types of storages. First is we have a volume storage, and second is we have a object storage. These are two types of storage we have in the cloud platform. We have volume storage and we have a object storage. Okay, we have volume storage and we have a object storage. That is a key thing we have to understand: volume storage and object storage. So let's say, for example, you go to AWS or you go to Azure, any cloud platform. So you are creating a VM. When you're creating a VM, if you want to store the operating system, or if you want to store the data, the only thing you can do is a volume storage. Like, let's say, for example, I go to my AWS, I want to deploy an instance. If I go to Azure, I want to deploy a VM. So what happens if I want to store something there? I have to use a volume storage, right? In AWS we call it as EBS volume. In Azure we call it as managed disk. So what happens? So this storage must be, if you want to access the storage, first of all, you have to connect this to an instance, and through the instance, you can access the storage, right? That's it. That's what we call as volume storage. And we have something called as a object storage. So before I explain you object storage, let me give an example. So I hope you're all aware of the platform called as Netflix. You're all aware of the platform called as Netflix. So what is the benefit of Netflix platform? It's basically a movie platform, right? We can basically watch movies, online TV shows and all. Basically, it's, it's basically giving us a lot of entertainment and all. Okay, right. So let's say, for example, there is a new movie released on Netflix. Assume that we have a new movie which is releasing on Netflix. When there is a new movie releasing Netflix, okay, when there is a new movie releasing Netflix, what is the problem there? Millions of customers, millions of Netflix users are accessing the same file at the same time, right? So what happens? Basically, if I'm storing this data on the volume storage, all these million requests has to transfer through the instance and to the movie, to the hard disk or SD. What happens? The performance will immediately go down, or the customers will affect a lot of availability and downtime issues, right? That's it. But at the same time, there is a storage called as object storage. So I know that those people who are not familiar with the cloud platform is not having an idea about this. That's why I'll give an example. So Google Drive is an example for object storage, not the enterprise thing, but still Google Drive is an example for object storage. In Amazon, we have something called as a S3. In Azure, we have something called as a blob containers. So what happens is when I basically go to the Amazon S3, okay, when I basically go to the Amazon S3, what happens is the Amazon S3 can basically store, okay, the Amazon S3 can basically store data, and we call it as objects. The data, any file or any data which is stored in the Amazon S3 can be called as objects. Got it? Any data or anything which we store on the Amazon S3 can be called as objects. Millions of people at the same time can access the data on the object storage. And let's say, but the only problem is object storage is not designed to get continuously modified. So team, my question here is it possible for me to modify some data in Google Drive without using another application? Let's say, for example, I have some data in my Google Drive. Is it possible for me to basically modify some data in the Google Drive without having third-party application? No, it is not possible. Let's say, for example, if I have a document file in Google Drive, when I click on that, it is opening with another application called as Google Docs. It is not possible for us to basically do the modification in this Google Drive or object storage kind of things. You have to basically put some data onto it. You can read it millions of times. We call it as worm technology. Write once, read many. Okay, that's it. Like the same way, we have different kind of storages. Like for we have a structured data and unstructured data for PaaS storage. We have an application level storage for the SaaS. So we have different kinds of storage types for like this. And you have to understand what all kinds of storages are there for the different storage types and the use cases. In the exam, they will ask you, they will give you a use case. The exam I have seen, there is a lot of use cases coming up in the next nowadays, and you have to basically understand the use cases, and you have to understand how these basically different storage devices can help us with each of them. Okay, that's it. Then understand what all threats are available for or are there for the storage type. Like for example, like the data security or data leakage. So basically we have a lot of threats in the storage types. You have to understand all that in detail. Okay, that's it. The next one is you have to understand about the design and apply. So we already discussed about the word called as encryption, and I give you one point there that encryption and key management is basically encryption is not possible in all kinds of data. That is why we basically have something called as a masking and tokenization. Like what is a tokenization? Like instead of sending the data, I am sending a token. It's a reference value. I'll give an example, team. I'll give a simple example. So you basically go to a supermarket with your car and you park your car in the valet. So what happens? They will give you a token. And once you basically return back after shopping, you can give back the token and get this your car, right? Like the same way, tokens will basically ensure that your transaction is not done, which is in an exposed manner. So you have to have an understanding of this. It's very important. And data masking is also called as data obfuscation. And we have a mechanism called as DLP. So team, what is the purpose of DLP? DLP means data loss prevention or data leakage prevention. What does it mean by data loss prevention, data leakage prevention? So when I say data loss prevention or data leakage prevention, that means that I have a data. I want to ensure that my data is not accessed by or not shared with or not copied by or not viewed by unauthorized people. So for that, I implement something called as DLP solution. So we have a lot of DLP solutions in the on-premise and the cloud also. So what happens if somebody tried to copy some data which is not authorized, or somebody tried to modify some data which is not authorized? What happens? They can basically have a DLP solution to basically block that. By using an effective DLP solution, we will be able to ensure that our data is basically not visible or basically copied or used by anybody, okay, that which is not authorized. And understand that when DLP can be implemented in the cloud also. In the cloud also, we have a lot of DLP solutions available, okay, that's it. Then we have a word called as anonymization. So anonymization means masking the data. That means it's all about ensuring that you're not having the PII, personally identifiable information. It can be direct or indirect. Any personal information is not visible, and it's completely removed is called as anonymization. So these things are very important to understand. You can expect a question from this technology, very 100% sure about that. And the next one is, see, I'll give a simple example. So in the case of anonymization, what happens is I'm giving you a data. Let's say, for example, now you're asking me, Krish, can you share me a sample resume? Example, you're asking me that, Krish, share me a sample resume. So what I'm do, I'll basically take a resume of one of my students, remove all the personal identifiers, his name, his contact number, his qualification, his college. So any direct or indirect identification which can basically point to him, I'm removing all that and sharing the file with you. The simple example for anonymization. Got it? So I'm taking a file, removing any kind of direct or indirect identifiers for a person or any entity is called as anonymization, and basically sharing it with you is called as it's okay. Then whatever things you're doing, you will not be able to see what or you will not be able to identify the person with that particular file. And tokenization means, let's say you're going to a supermarket, you buy something and basically give you a credit card. So what happens? They basically swipe your credit card in the point of sales machine, and the POS machine will basically send a token instead of sending your data. Why? Because if they send your data, in between there's a higher chance of security risk and attacks. But at the same time, if they send you a token for that, what is the advantage there? By sending a token, they can have more clarity. Okay, by sending a token, they can have a more clarity. So what happens? The token is not having any kind of sensitive information. It is just a reference for your actual data. Like for example, like the paper they are giving for in receipt of your car for just keeping it for 2 hours. Got it? It's basically same as masking. Data obfuscation masking is same only. Like basically masking means, let's say for example, it's a part of anonymization only. So what happens is I have a data. In the data I'm masking the sensitive information is called as obfuscation and masking. Both are same only. Okay, that's it. So then we have something called as a data discovery and classification. Data discovery and classification. What does it mean by that? Let's say, for example, I have a data. So if I want to protect the data, first of all, I want to know what all things I want to protect, right? Let's say, for example, if you want to protect the data, first of all, you have to classify the data. If you want to protect the data, you have to classify the data, like sensitive data, non-sensitive, public. You have to basically classify the data if you want to protect it, right? So the way of classifying the data is always based on the sensitivity. So you classify the data based on the sensitivity and value of the data to the organization. Okay, you basically classify the data based on sensitivity and value to the organization. So for classifying the data, you have different mechanisms. By having proper labels or tags or other information, you can basically discover and classify the data. And once you classify the data properly, you will be able to very effectively apply security controls. And understand that if you are not able to properly classify a data, it can basically lead to poor or improper security controls. Exam critical point. If you basically fail to protect your data, it can lead to poor security controls. Don't forget. Okay, that's it. If you fail to basically protect your data, it can lead to poor security controls. Don't forget. Okay, that's it. Or if you fail to basically properly classify your data, it will lead to poor security controls. And then you have to talk about IRM. So I'll give a simple example. So I know that basically this IRM is not a familiar word for all of you, but we can call as DRM. It is more familiar. The enterprise level DRM or data rights management is called as IRM. I'll give an example, team. Let's say I'm having a firewall, I'm having a DLP, I'm having all these solutions. What if the data is, I am sending the data to somebody else? Let's say, for example, I am sending a sensitive information to one of these people here. Example, when I am sending information to you, all these controls like firewalls, IDS, IPS, access control, this DLP solutions and everything is applicable until it is inside your organizational boundary, right? What happens if your data is leaving your organizational boundary? Let's say, for example, now I'm sending you a file. Example, if I'm sending you a file, and once I send you a file, what is the guarantee I have? How can I basically enforce security controls on my data? Like I'm telling you, team. So please, I'm sharing your file. Example, I'm sharing your file. Let's say this file I'm sharing with you. So once this file is, I click on send in the email. I am just clicking on send. And once the file is sent, you receive the file, right? And once you receive the file, what is a guarantee that what is the guarantee I have that I can have some security on this data, or I can basically have control of this data? Nothing, right? That is where this IRM or DRM solution can help. So I can basically have the control on my data even after the data is not inside my premises. I'll give an example. Team, have you seen there is anybody who is here who is certified on the CEH or any kind of certification like that? When you basically go to this Easy Council certifications and all that, right? They will basically let you download the materials. Okay, like you can download the study guides and all. But the problem is this guide will only work in your laptop. Or let's say, for example, certain files when you open, it will work only for 30 days or let's say 40 days, something like that. Why? Because we can basically make a timeout. We can basically have controls. We can have a remote wiping. We can have a remote erasing. We can have a file expiry. A lot of things like we can configure with the help of DRM or IRM solutions. Or I'll give you a more effective solution. I'll give you something called as email-based DRM. Let's say, for example, I am sending an email to Steven here. Example, out of this list, I am sending an email to Steven. When I am sending an email to Steven, if it is basically reaching some person who is not supposed to reach, that the content must be not be exposed. What happens? The file or the content will not be able to download. Why? Because the email will basically specify that this is only applicable to this particular person. Like the same way, once the data is out of your organization control, if you want to protect, you can basically use a IRM solution. Okay, that's it. Then we have to understand about the most important thing called as data retention policy. Data retention policy. So what do you mean by data retention policy? That means that you have a data. When you have a data, for a lot of compliance things, you have to keep the data for a long time. For example, if you want to basically comply with the HIPAA requirement, you have to basically have at least 5 years. You have to keep your data. Like the same way, for every kind of things you're doing, you have to keep the data for a long time. Like for example, let's say if I'm basically having PCI DSS compliance, sometimes I have to keep it for 11 years. So I have to basically keep the data for a long time for a lot of compliance reasons, right? That is why there is something called as a data retention policy. That is how long I have to keep my data without erasing it and how I have to delete it. And when I say deleting it, what we have to understand, always remember the word called as crypto shredding. And to save money and to basically have more effectiveness for the cost and all, I can basically use a data archiving. And the next one is I have a legal hold. Like for example, due to any reason, if I have a legal hold, what happens? How can I basically preserve my data? And definitely we have to understand about the logging, storage analysis, analysis of data events, chain of custody, non-repudiation, all these things. Okay, that's it. Now we'll discuss about the domain 3, the cloud platform and infrastructure security. So the domain 3 and domain 5 is sometimes you will feel like it is more specific in the perspective of a cloud service provider, because you know that when you go to the cloud platform, it is not you managing it. The cloud service provider is managing the infrastructure and all, right? So you have to understand that basically when you go to domain 3, it's all about, in the most of the things we're discussing is basically in the perspective of the cloud service provider. But I have seen many students basically miss these topics in the exam because they are not thinking in the cloud provider's perspective. This domain is very sensitive one, you have to understand. Okay, that's it. You have to understand the various components of the cloud infrastructure, like physical environment. Understand that physical infrastructure is always the responsibility of the cloud service provider, and how the communications are happening, how they have to point the network, what is a compute pool, what is a network pool, what is a storage pool, all these things you have to understand. And this is super important for us. In the cloud platform, how do you do all these things? The main way you do something in the cloud platform is to have a management plane. In the cloud platform, the most important thing you do in the management plane only, right? Domain 3 is also 17%. Domain 3 is also 17% of the exam. Okay, see, basically in the exam or in the while you're learning also, if somebody asks you what is the prime or what is the single point of failure in the cloud platform, okay, what is a single point of failure in the cloud platform? The answer is management plane. The management plane is always acting as a single point of failure. Don't forget, the management plane in the cloud platform is always asking as the single point of failure. Okay, why? Because in the management plane, what happens is, let's say for example, you have a cloud console, right? In the cloud console, okay, so you basically have your VMs, you basically have your storage, you basically have your DB and everything in the cloud management plane. So if the cloud console, if the AWS management console or if the Azure management console or if the cloud management plane is compromised, your complete infrastructure is compromised, right? Your cloud management plane is compromised, your complete infrastructure is compromised, right? So that is always a risk. So there must be mechanisms to ensure that the cloud management plane is secure. And the primary mechanism to ensure the security of cloud management plane is to have a proper authentication, authorization, and accountability. Don't forget, the primary mechanism to ensure the security of the management plane is to have proper authentication, proper authorization, and to have proper accountability by logging. Then the next thing which we have to understand in this perspective is the design a secure data center. So here you have to understand that when I talk about the design data center, we have to understand we have two levels of design. We have a logical design, we have a physical design. So team, when I'm designing something, which one will come first, a logical design or the physical design? Which one will come first? When you basically go to any infrastructure, the logical design will come first. To make it more simple, I'll tell you an example. So what happens is when you basically go to, let's say you're going to AWS or any cloud, let's say you're planning to build a home, build a house, you will do the diagram first, you will do the plan first, right? Like the same way, you have to first of all understand the logical design. What does it mean by that? It means that how you are basically planning to or what all things you're planning to provide to the customers. Are you planning for a multi-tenant architecture? What kind of services are you planning for? IR services or PaaS services or SaaS services? How are you planning to give access control? Like we have to basically discuss about or understand about a lot of logical factors, and based on the logical design factors you have, like for example, where is the location of my customers? So based on all these logical factors, we have to do the physical design of the data center. Okay, based on the logical factors, we have to do the physical design of data center. And don't forget, in the exam, the key point, the physical design of a data center is closely related to the environmental design. Don't forget, like you are planning for a physical design, so understand that in how much temperature, how much humidity, how much moisture is there in the infrastructure, in the environment, and based on that you have to plan the physical design. Okay, that's it. And there is a word called as multi-vendor pathway connectivity. That means that instead of relying on a single provider, I'm talking about the cloud providers from my perspective. As a cloud service provider, instead of basically relying on a single provider, I have to basically have multiple vendors providing me connectivity, so that even if one provider goes down, still I'll be able to serve my customers with the backup providers. Okay, that's it. So this is a very important question most people ask. Analyze the risk associated with the cloud infrastructure. So team, my question here is, let's say you know that basically in the on-premises you have a lot of risk. You're moving to the cloud platform. So when you move to the cloud platform, will the risk increase or decrease? When you move to a cloud platform, will the risk increase or decrease? Okay, definitely the cloud risk will increase. Don't forget, when you go to a cloud platform, understand that the risk will always increase. Okay, the risk will always increase. Got it? I'll tell you. See, you already have a lot of risk. The same level of risk is there in the cloud platform also. Plus, they introduce some additional risk like multi-tenancy, third-party administrators. They are introducing a lot more risk also, like data residency. So what happens? But the risk you're taking, the value you're getting is more than the risk. And you have to understand how to manage the risk. Like we have different strategies for managing the risk, like risk avoidance, or let's say risk transfer, risk acceptance. Like we have a lot of things like that. So what is risk avoidance? So I know that basically there's a risk. To avoid the risk, I am choosing an alternate mechanism. Like the same way, we have to understand various kinds of risk mechanism mitigation things, like risk management things like risk mitigation, risk avoidance, risk transfer, risk acceptance, and all that things. Okay, that's it. Then what all things we have to basically do for implementing security in the cloud platform? Like for example, what are things they have to do for physical security and environmental security? Like for example, how to ensure that the people are basically, or safety of the physical infrastructure, what all things are there to protect the barriers, like the access control mechanisms the cloud provider is having, how the cloud provider is ensuring the security for the hardware they have and the infra they have, and how the virtualization is protected. Basically, we have a lot of mechanisms to protect the virtualization, how the virtualization is protected, and always the main thing, identification, authentication, and authorization. Okay, that's it. And when you say the word so all these things, when you say the word RTO, or sorry, BC or DR or anything like that, you have to clearly mention this in the SLA. Don't forget, if this is not properly mentioned in the SLA, you can't have a security. Don't forget. So basically planning for the disaster recovery and business continuity is very much challenging. So you know that the cloud provider provides you a lot of things. I'll give a simple example, team. So in the cloud provider, how can you ensure DR? How can you ensure a business continuity? Let's say in AWS, how can you ensure business continuity? Or who is responsible for that in the cloud platform? So what happens is when you basically say the word business continuity, you know that the cloud service provider is providing you with the regions, availability zones and all. But the business continuity is always your responsibility. So what you have to do? You have to plan accordingly. Let's say, for example, now all my infra is running on AWS. What if AWS completely goes down? Let's say, for example, AWS is having a data center in Mumbai. So what if AWS completely goes down? Even if AWS completely goes down, I have to ensure that the business can continue operating, right? By ensuring that I have a backup cloud provider like Azure. So even if AWS goes down, I can run with Azure. Like the same way, I have to understand the various business continuity and disaster recovery factors and various risk in the cloud platform, the business requirements like RTO, RPO, etc., and all these plans. Okay, that's it. Then we have a domain for one of the most important domain. It's also 17% the exam domain for cloud application security. So team, I'll give an example. So when you basically heard or understood or heard about this cloud platform, which year you basically heard about this cloud platform? I basically started on this cloud platform in 2010 only. So which year you basically heard about this cloud platform? Okay, some people basically say, okay, they are from 2015, 14, 11, whatever it is. Yeah, perfect. So for everyone also, anyway, most people are basically familiar with the cloud platform only after 2008 only maximum. Anyway, basically after this only, basically most people are, or we can say 2010 actually, most people are basically have this word called cloud computing. Even if this word was there for a long time, this is the first time this is basically the hit in the market only from that particular, this 2000 like 10 and all. So what happens is when you see, let's say for example, I am having an application in my company, I'm having a legacy application in my company. When I have an application in my company, you know that that particular application is not designed with cloud in mind, right? When you have an application, you know that this application is not designed with the cloud platform in mind. See, 10 years back or 15 years back, when I developed an application for my company, you know that that application is basically not designed with the cloud platform in mind. That application or that platform is completely designed, okay, designed for on-premise, the security controls, the application architecture, the application structure, and everything is basically in the on-premises manner. So because of that, the applications are not able to easily lift and shift to the cloud platform. Don't forget, it is not easy for us to basically lift and shift. We call it as forklifting. It is not easy for us to lift and shift the application to the cloud platform. Why? Because it is not designed for cloud in mind. Okay, these applications are not designed with cloud in mind. So what happens is if you have an application, these applications is purely designed for on-premises. So when you try to move this application to cloud, you may face a lot of challenges. Like sometimes there is no compatibility. Sometimes it is not possible. Sometimes the application can't work in a virtualized environment. So basically, it may mean on-premises. So you have to understand how you can basically transfer the existing application from on-premise to cloud platform. And when you are developing an application for the cloud platform, what all things you have to keep in mind. I'll give an example. So let's say, for example, most people ask me, Krish, I'm a developer who is basically working in a company. Do I have to learn cloud for anything? 100% yes. If you're working in a company and if your company is planning for a cloud model, if you want to develop an application, you have to know how they are providing the services, right? Let's say if I want to develop an application which can work in the cloud platform, you as a customer, you have to know, or as a developer, you have to know that this application is basically working in an IaaS model or PaaS model or SaaS model, right? How do I know that? By using a proper cloud learning strategy. You have to learn the cloud platform, and then only you can develop the applications effectively. And definitely in the on-premises, we have a lot of application vulnerabilities, like you can basically refer to the OWASP top 10 OWASP top 10 application vulnerabilities, like SQL injection, cross scripting and all. More than this, the cloud is also having a lot of other challenges like multi-tenancy, service models, a lot of other challenges there in the cloud platform. So basically we have to understand all these things for the exam. The next one is we have something called as a SDLC. So what is an SDLC? It's a well-established proper model or strategy for designing and developing an application is called as SDLC. And definitely SDLC is there for a long time, and we have different models for SDLC, like the agile model, the waterfall model, the V model, the spiral model. We have a lot of models for doing SDLC, but we have to understand that we have to understand how this SDLC can be done securely. Like for example, let's say you are planning to implement SDLC, but now we have to think about security. So you, as a CCSP, you have to understand the concept of secure SDLC, how to integrate security in every phases of the software development lifecycle. That's what you call as secure SDLC. Okay, that's it. That is something which is very important for all of us to understand, secure SDLC. And basically the steps are same only, but in the secure SDLC model, you have to understand like where the threat modeling will fit in, where the defense in depth will fit in, where the security will fit in. You have to understand in every phase how the security can basically fit, and basically having a proper strategy for ensuring that the applications and everything are basically secure, and the common mistakes which you make while development can be avoided. And team, what do you mean by threat modeling? Means identifying the various kinds of threats or various types of threats or various levels of threats applicable for my application is called as threat modeling. So for doing threat modeling, we have a lot of models there. For example, let's say stride model, then we have a dread model, pasta. We have a lot of models are there like this for doing the threat modeling. Okay, that's it. The next one is you have to understand that how we basically do the cloud software assurance and validation. So basically you have to understand that what all things are basically there for the proper security. So I'll give a simple example. We have a process called as VA and PT. What is VAPT? Vulnerability assessment and penetration testing. So team, what is the difference between having a VA and PT? What is the difference between doing a vulnerability assessment and pen testing? So vulnerability assessment means we are trying to identify the process of identifying known vulnerabilities is called as VA, vulnerability assessment. We are trying to identify the known vulnerabilities. That's what we call as VA. And trying to see how much these vulnerabilities can be exploited is what we call as penetration testing. And how can we basically ensure the application security? And you basically learn this, you have to understand two words called as SAST and DAST. SAS stands for Static Application Security Testing, and DAST stands for Dynamic Application Security Testing. The difference is when you do a SAST, you are verifying the code only. You are testing the code is what you call as SAST. SAST is all about testing the code. Don't forget, SAST is all about testing the code, and DAST is all about testing the application. So we call it a SAST, is also called as white box testing. And yeah, definitely Heather. And the DAST is also called as black box testing. So don't forget team, VA means basically scanning the application or scanning the infrastructure to identify the known vulnerabilities, identify the non-vulnerabilities is what you call as vulnerability assessment. To identify the vulnerabilities, we are using some mechanisms on benchmarks is called as vulnerability assessment. And penetration testing is all about exploiting the vulnerabilities. So I know that there is a vulnerability. By utilizing the vulnerability, can I basically compromise something, or can I get some information? Can I basically provide some information? That's what you call as penetration testing. Okay, that's it. Then you have to understand what is an API. In the cloud platform, if you don't learn API, then we can't work in the cloud platform. Why? Because APIs are the key in the cloud platform. See, now you basically go to a cloud provider. Let's say, for example, now I'm going to my AWS platform. So I'm going to delete some files. I'm going to create some files. I'm going to create a server. I'm going to open S3 bucket. I'm going to open EC2. So whatever things I'm doing in the cloud platform, we are issuing something called as API calls. API call. Okay. So whatever things we are doing in the cloud platform, we are basically issuing something called as API calls. So what is an API call? API call means, let's say for example, let me give you a simple example here. Let's say for example, you go to a hotel. You basically go to a hotel and you order some food. Who will take the order? The person who is serving there's a waiter will basically come to you and take your orders. And he is not preparing the food for you. He will basically take your orders, go to the kitchen, take the food and serve it to you. The same is done by the APIs. To make it more simple, I'll give an example team. Let's say for example, we have an application. Let's say I am developing a website here. When I'm developing a website here, what happens? Let's say I want to have a map and navigation in this example. In my website, I want to have a map and navigation option. So if I basically go behind developing a complete map and navigation option, it will take a lot of time and effort for me, and by the end I am diverting from my business. So what I can do there, I can basically use something called as a Google Maps API there. I can basically something called as a Google Map API. So what happens when I use a Google Map API here, this API will basically bring the functionality of Google Map to my website. To make it more simple, I know most people are available from Uber. You have a platform called Uber, right? So using this Uber platform, when you open this platform, you can see a map application, but that map application is not belonging to Uber. That is designed, developed, and working by Google only. So Uber is using the API of that particular application. Okay, that's it. That's what we call as APIs. In the cloud platform, whatever things you're doing, you're actually making API calls in the backend. And then we have a word called as supply chain management. We have a word called as supply chain management. What does it mean by supply chain management? Supply chain management means, let's say for example, now I am planning to develop a software. So I'm outsourcing I'm outsourcing see, API is something which will help us to basically in the backend do the automation orchestration. But API, API is all about making the calls to the cloud platform. You have a cloud platform, you are basically making some call to the cloud platform. Okay, and this API is something which will help us to basically go to the cloud platform and do the command for us. So it is done by the orchestration layer. Okay, then we have a word called as supply chain management. So let's say for example, I am basically having a business requirement for developing an application. So when I am having a business requirement for developing an application, so what I'll do, I will basically outsource the requirement to a company, and that company will basically outsource the requirement to another company, and again that they give it to another company. So what happens, we have a supply chain there, and having a supply chain can be a very much challenging for us. So before you basically enter a contract, you have to understand what all providers are basically giving the supply chain to the cloud service providers and third party software management as well. That's about the application security. And then we have to understand the various components for securing the application in the cloud platform. For example, we have something called as a WAF. What is a WAF? Web application firewall. So team, normally what happens is when you have a normal firewall, it works in the layer 3 and layer 4 of the OSI reference model, but WAF works in the layer 7. So it is more about specifically in the application layer. So normally what happens, a firewall can protect you from the traffic. Like if you have an incoming traffic and outgoing traffic, you can filter based on the protocol, port number, source IP, destination IP, and all. At the same time, when you go for a WAF application, when you basically go for a WAF application, what happens is this WAF application is, or WAF is a it can be application or hardware. It will basically help us to scan the application layer packets and to see if there is any kind of application level vulnerabilities like SQL injection, cross-site scripting, and all. Okay. And then we have a DAM called as database activity monitoring, which will basically ensure the database is basically secure. And we have different like other kind of firewalls, and to restrict the number of APIs, we have an API gateway and all. Okay, that's it. So IDS IPS work in layer 4 and layer 3. So basically what happens, they can also work in layer 7 when compared with this and next generation firewalls and all. Okay, that's it. The next one is we have a sandboxing. So sandbox cryptography we already explained. Sandboxing means what? Let's say for example, I now my company is telling me, Krish, please test an application. I want to test an application. So when I basically test an application, what happens is this particular application, if I am testing it, okay, if I am testing it in my computer, there is a higher chance that if there is any malware in this application, it can affect my system. If there is any kind of instability in my application, it can affect my operating system. So if I install the application, sometimes my OS can also get corrupted, right? That is why what we can do is we can basically use something, we can basically use something called as a sandboxing. By enabling sandboxing is not a feature, it's just a it's just a playground for testing, nothing more. It's just a playground for testing only. So what happens, we can test the applications. Okay, we can basically test the applications more effectively. So it provides me a secure platform which is completely isolated from the other platforms. So what happens, so whatever things I'm doing, it will be only inside that boundary. Then we have a design appropriate IAM solutions. So let's say for example, team, the main challenge every company facing is basically they have a lot of applications and a lot of services. The companies must have a mechanism to ensure that we must be able to, or their users must be able to log into multiple platforms and multiple vendors. Like for example, let's say in your company there is a user who is using the Microsoft Active Directory. You have a user in the Microsoft Active Directory, this Microsoft AD user must be able to log into the cloud platform using the same credentials. Like the same way, I must be able to generate a credential in or token in one cloud provider and use the token in another cloud provider. That's what we call as federation. There's a lot of standards for federation like the SAML, like the OpenID, OAuth, etc. So basically these standards are something which will help us to do all these things. And then we have a SSO. I'll give a simple example for SSO here. Let's say, for example, now I am opening my browser. I'm opening my browser and I am opening Gmail. Okay, in my browser, I'm opening Gmail. So when I basically open Gmail, what happens? They will ask me for my username and password, right? So I enter my username and password and I am authenticated. So if I open Google Drive in the next tab, I'm opening Google Drive in the next tab. Do I have to log in again? No. Why? Because I'm already authenticated. So once it's done, I can basically reduce the number of sign-ins I'm doing. That's what I call a single sign-on. Okay, that's it. And for having proper authentication, there must be something called as a multi-factor authentication. I'll give an example, team. If you want to say multi-factor authentication, you must have three things. First of all, something you know. Something you know. Second is something you have. Third is something you are. So we must have three things, something you know, something you have, and something you are. So let's say, for example, something you know means like the pin numbers, or let's say some patterns, some passwords. All this is called as something you know. Something you have means some key files, some certificate files, OTP, etc. is something you have. And something you are is your biometrics. If you want to say multi-factor authentication, you must have any two of this. Can't have only one. If you want to say multi-factor authentication, you must have any two of this three, at least minimum two of this three. Okay, like it can be like something you like when you log into Gmail, they will ask you for a username and password. When you enter the username and password, they will ask you for a OTP. That is multi-factor authentication. Okay, that's it. And you have to understand the relevance of a CASB provider like Aviatrix, and basically a lot of CASB providers in the market like McAfee is providing CASB solution. A lot of companies are basically providing CASB solutions. Dell Boomi. So what is a CASB solution? The CASB provider can help us to basically ensure that my identities can be managed and the identity and access control can be managed effectively. Okay, that's it. Across multiple cloud providers. Then we have a domain called as domain 5. The domain 5 is all about the cloud security operations. You will feel the almost the domain 5 and domain 3 is almost same. The reason is because the domain 5 is also more from the cloud provider's perspective. Okay, that's it. First of all, in the domain 5, we have to understand the various physical and logical component security. Like we have to understand the security factors of the BIOS, the TPM module. TPM is basically an encryption, the secure chip which we can use in the computers. Like those people who basically work in the modern enterprise laptops, you have a fingerprint scanner, right? The fingerprint scanner nowadays is basically integrated with the TPM device. So what happens is it can provide us more security. Then how the cloud service provider can install and configure the various virtualization management tools and what all things they have to keep in mind, and how they are basically able to secure the configuration. Like for example, let's say in the cloud, in the virtualization, they have a lot of VMs and all, right? When they have VMs and all, how can basically they enforce the segregation? How can they ensure that proper RAM, proper CPU capacity, and everything is available for each and every VM? So all these things we can do with the help of virtual hardware specific security configuration requirements. Then we have a guest OS. Understand that when you go to the cloud service provider, the OS you are getting is called as a guest OS. The OS which you install on the virtual machine is called as the guest OS. And how can we basically ensure the security of the guest OS? Understand that if you go to IaaS platform, the guest OS is completely the responsibility of the cloud service consumer, that is a customer. At the same time, when you go to any other platform, the OS is completely the responsibility of the cloud-based provider. And the next is how you have to ensure the security. Okay, how you have to ensure the security of the various access control or access to the cloud platform. I'll give an example. Now when you go to the cloud platform, you're accessing your servers with the help of different protocols like RDP, SSH, things like that, right? So how can you basically ensure that these protocols can basically give you security? And how can we ensure that the cloud service provider is providing proper segregation and you know that the cloud service provider is providing you separation or providing you segregation with the help of something called as logical mechanisms. Like we have a VLANs, they have a lot of mechanisms like VLANs, access control list and everything to ensure that we have a proper segregation. Okay, that's it. And how to set up a baseline for securing the operating system. As a cloud service provider, how I can basically ensure the security of OS and everything by establishing a proper baseline standards. And if the customer is requesting for a dedicated hardware, how can we basically ensure the availability of it? And while using the various shared hardware or clustered hardware, how can we ensure the performance and security of it? Okay, these things are what we discuss in the operate physical and logical security for the cloud environment. Okay, that's it. And this is the largest domain in the CCSP exam. Don't forget, this covers almost 19%. This is basically 17%. Sorry for that. This is basically 17%. The largest domain is domain 2. This is basically covering 17% only. So then when you go to manage physical and logical infrastructure, what happens is the same thing, how you can ensure security. Like what is the importance of having a patch management? What are the best practice for doing the patch management? Can we enforce automation in that? Or how to have a proper monitoring and how to have a proper monitoring solution, like how to have a proper SIEM solutions and all, and how to basically enforce various controls like firewalls, IDS, etc. And I'll give an example, team. Tell me, team, what is the primary purpose of a honeypot? When you basically go for a honeypot, okay, in the company, what is the primary purpose for a honeypot? So what happens is basically most people think that the goal of a honeypot is to, or the goal of a honeypot is basically to, to know what the attack, or basically trick the attackers. The primary intention of the honeypot is not to trick the attackers. The primary intention is basically to learn how the attackers tactics. See, attackers are daily using their various new mechanisms to attack, right? So to learn this new attack techniques, to learn this new attack tactics, they are using honeypots. Okay, then we have something called as a management plane. So management plane, that in the cloud platform we have a management plane. So you have to understand how to secure the management plane effectively. What are the best practices? And we have a lot of things to understand here, called as the ITL standards and all, like the change management, the continuity management. All these things are very important for us. To make it simple, team, what is the change management? Whatever things you're doing, let's say for example, if I'm planning to implement a new hardware, new software, new patching, new VM, so whatever things I'm doing, it must be taken through the change management process prior to the change taking place. Don't forget, before a change is taking place, it must be taken through a change management process. Prior to a change taking place, the change must be taken to a change management process. Don't forget, okay? That's it. Prior to a change taking place, the change must be taken to a change management process. And then we have to understand all these things in a very detailed way. Don't forget, team, this is something which is very important for us to understand. And you have to understand the difference between all these things. I'll give an example, team. So most people basically ask, what is in the exam also they'll ask, what is the difference between incident management, problem management? The role of the incident management is to bring the service back to operation as soon as possible. Okay, the goal of an incident management is to address the issue and to bring back to operation as soon as possible. And the goal of a problem management is to understand the RCA, root cause. And the problem incident management, we will basically trigger the incident management and to ensure that we are back to operation as soon as possible. And the role of a problem management is to understand the root cause for the incident. Then we have to understand the data forensic, digital forensic mechanisms, like how we are basically, supporting the digital forensic, like for example, how the data is collected. Like what is a primary challenge, team? When you talk about the forensics, the primary challenges, you can't have access to the infrastructure. See, when you have forensics in the on-premises, it's more easy, right? When you have forensics in the on-premises, it's basically more easy. At the same time, when you basically want to have forensics in the cloud platform, okay? When you basically have forensics in the cloud platform, you are relying very much on the cloud service provider, okay? You are relying very much on the cloud service provider. You have to understand what exactly the cloud service provider is allowing you to do. Got it? Like for example, if my cloud provider is not allowing me to collect the data, how can I do the forensics? So in the cloud platform, primary challenges, you have to rely on the cloud service providers option to basically give you the data for forensics. Okay, that's it. Then how to ensure that the communication with various parties, and how to ensure we have a proper log management, how to ensure having a proper SIEM solution. So team, what is SIEM solution? Let's say, for example, I have a lot of log files. When I have a lot of log files, how to ensure that these log files are properly analyzed? It is not possible for me to basically go and analyze each and every log files, right? We can't basically go to log files separately and analyze it, right? Like for example, let's say if I have some log files, I can't basically open every log file and verify it. Why? Because I can have millions of log files. That is why I basically have to go to a SIEM solution. The SIEM solution can basically take the log files from various locations and they will be able to analyze it very effectively. Okay, that's it. And the last domain we have a domain 6. It's been just 13% only. It's a small domain, legal risk and compliance. But even if it's a 13% domain, it can be a bit confusing because it's completely about the legal factors. You have to understand that the legal conflicts in the cloud platform. To basically give you a very simple example for the legal conflicts, let me give an example. Let's say I have a company which is operating in India. My company is basically registered in India. My customers are from Europe. My employees are working from US. My data center is in Singapore. Which law they have to follow, team? Which law of country they have to follow? Let's say I have my company registered in India. My customers are basically from European region. My employees are working from US and my data center is in Singapore. So which country law we have to follow? Most people say definitely the law of the country where the customer is located. Like for example, let's say if I'm processing the data of European customers, I have to comply the GDPR. Like most people say that where the customers are in, you have to basically follow the rule of the country. But definitely I'm storing the data in Singapore. I have to basically follow some Singapore also laws also, right? When a company is in India, they have to follow Indian laws also, right? So we have a lot of legal conflicting factors like this. So these kind of factors must be able to address. That is very important point. Understand that the cloud platform brings you additional issues of this legal and other factors. So ensure that you basically make sure these conflicting legal factors is addressed properly and effectively. And then how we can basically evaluate the risk specific to cloud platform. Basically, the cloud platform is basically global. So what happens? It can also bring us a lot of risk in this legal factors as well, and the various legal factors like APEC and everything, OECD and everything, which will help us to do that. And we have a e-discovery. E-discovery is basically the process of collecting the information for forensics is called as e-discovery. And what is the standards for that? Understand the difference between data and privacy. Understand the difference between having a data and privacy, how the contractual data and how the regulations are affecting. So let's say, for example, two parties are having a contract, and basically we're working in a country. Which will come first? The law of the country will come first, then only the contract. And how the various jurisdictional differences can affect the data privacy, okay, and the various standards for it. Okay, that's it. Then we have to understand the various audit mechanisms like the internal and external audits. And team, let's understand that which is more trustable, which is basically trustable to customers, internal or external? External. Why? Because internal is basically for quality improvement purpose, and external is basically by a third party, which will basically increase the trust to the customers. Okay, that's it. We have to basically follow all these things. It's very, very important things. We have to basically understand the various standards and regulations like gap analysis, and understand the standard and the regulations like the HIPAA, NERC, PCI, a lot of things like that. Okay, that's it. And understand the cloud platform policies are the key to everything. Don't forget, the cloud platform, the policies are the key to everything. Don't forget, if you want to enforce something, there must be a proper policy for that. And how to basically have a proper risk management, like what are the factors we have to do for ensuring the proper risk management, like who is the data owner, who is the data custodian, and how to enforce the risk. And understand that we can't transfer certain risk to the cloud provider. Whatever things we're doing, we can't transfer certain risk to the cloud provider, like the data compliance risk and the company like the organizational reputation risk. All these things cannot be transferred to the cloud service provider. Okay, that's it. And understand the importance of having a proper SLA and how to have a proper vendor management, contract management, and supply chain management. This is the whole topics which we have in the CCSP exam. Okay, now, and team, I hope you are able to follow. Tell me if there is a doubts you have. I'm just giving an overview only. Okay, so now most people, and the next thing most people ask me is what all resources you have to use for reading for the exam. So materials can help you to basically prepare for the exam. So basically you can see there's a lot of materials available in the market for the exam. but the most commonly ones I prefer you is basically the first one is basically the CCSP all-in-one study guide, second edition. This is the primary reference material I always prefer you to read. A CCSP all-in-one study guide, second edition. Okay. The second study material I wanted to prefer for CCSP is CCSP for Dummies. This is just a basic one. This is just an optional thing, but you can basically go for it if you want. Okay. Then the third one I prefer is the CSA guidance. Is basically available free of cost. Okay. And the fourth one is basically the CCSP official practice exams. This is basically available by Cybex by online. Basically, go through the latest edition only. Don't go for the old one. And we have some other documents like basically the the document which is available in the CSA guidance on the CSA website and all. This can basically give you a clarity. Okay, these are the key things I wanted to basically refer for the exam. And a few more things I want to tell you on this team. Just give me a second. I'll give you some more tips on this. But before that, just one more thing. So understand that team. If you want to pass the exam, the whole thing is understand the concepts very clearly. How much more you understand the concepts clearly and how much you can correlate, that much easy you can pass the exam. Okay, that's it. And a few things I want to basically discuss on this exam. Like when I'm basically trying to explain certain points, right? When I basically try to explain some points, the primary thing people will have a doubt is about, Krish, this is not the best practice in my company. Like for example, let's say when I discuss about some kind of things, people will say, Krish, this is not what we are following in my company. Understand that the CCSP exam is not about the best practices for on your company. It is basically generalized and basically talking about the general best practices. It's not about the best practices in your company. No, it's not. You have to think like a manager. If you want to pass the exam, your exam perspective must be like a manager. I'll give an example. So let's say you're not the person who is supposed to sit in front of the computer. So if you're basically if you're a person who is having a technical experience, you have to think about the perspective of a manager. I'll give an example. So let's say, for example, we are talking about a serious attack in my infrastructure. When there's attack happening in my infrastructure, what happens? As a CCSP, it's my responsibility to ensure that the proper incident response plan is followed and it's notified to the management. So it's more from a management perspective. Like if you want to know the importance of certain things, you must be having some experience or some knowledge in that. And this exam is purely international. It's not a country specific exam. And don't forget, this exam is not biasing to any cloud service provider. This exam is not biasing to any cloud service provider. This exam is purely generically on the industry. And understand that we are not focusing on any industry like like government industry or let's say banking, hospital. We're not based on any kind of industry like that. Okay, that's it. Then a few more things I want to discuss. Okay, and when you write the exam, I have seen that the key things which most people miss is these kind of words. The exam is trying to test you the concepts and best practices and skills. So what happens is when you basically miss these kind of words, let's say for example, in the exam, if you're getting a question, I'm getting a question in the exam. In every question, you have to understand that there is a lot of key points which will point you to the proper answer and certain distractors. So by reading the question carefully, you must be able to understand the key points and distractors, and you'll be able to easily answer the question. But I have seen that many people basically confused with the terminologies the IC square is throwing us for you. Okay, that's it. And these are some key points we have to remember. Whenever I talk about security, people safety come first. People, process, technology, people always comes first. Then for anything you do in your company, there must be well-established policies. And whatever things you're doing, it must be approved by the management. Don't forget, whatever things you're doing, it must be approved by the management. Okay, it must be approved by the management. And whatever things you want to do, education, and make sure you basically learn things, or your company team must be learning things to work effectively. And the security is the responsibility of everyone. So what happens is anything a person can do will circumvent technical controls. Okay, that's it. And understand that the CCSP exam is very simple. And this is something which I recommend as a pre-reading for the exam. If you want to basically get the exam passed, okay, or before going to the trainings, if you want, you can basically go to this particular file. This is something which I strongly recommend you can go through. called as a CSA guidance manual. Okay, you can basically go into the CSA guidance manual. This is the best one. I strongly recommend for you. Okay, this textbook is basically this 120 pages. This textbook will give you a complete in-depth reference for your CCSP or CCSK journey. Okay, that's it. Just fill in this thing, something, just you can fill something here. Just put some name, just enter some information, and you will be able to just select your region and you'll get the download link. Download. This is the latest version you can download from the ICQ guidance, the CSA website, and this will basically give you a complete idea on the exam. See this, even if it's for the CCSK, before CCSP, I strongly recommend you read this textbook. The whole domains in CCSP, the total 6 domains in CCSP is divided into 14 domains in CCSK. That's the only difference. And it will definitely give you a complete overview of the practices. See, the same thing we discussed: risk management, cloud architecture, legal risk and compliance, information governance, data security. See, everything is here. The same thing we discussed in the other thing also. See this, everything is here only. This will give you a very good idea for you. This must be a very good reference for you before the learning or after the learning. This can be very good reference for you. Okay, that's it. And I strongly recommend you can basically go for this document called as NIST document also. Okay, that's the whole thing about this. Thank you so much, team. Bye, team. Have a nice time. See you soon. Bye, everyone.